And we are live, folks. Day 2 of the build platform coming at you. It is Ms. Vicky Soma and
Good morning.
myself for the moment. Excellent, excellent. How's everybody doing? I've been watching the chat over on the YouTube channel a little bit. Seems like people are excited for Slice to be coming up as they will be kicking things off. If anybody has been watching channel 1, and why would you not be watching channel 1, you guys will know that Slice just jumped on there for their time period. And so they will be moving over here right after that happens, which should be at exactly 11:30, which would be just in time for them to start their presentation here. So we got a couple of minutes to kill, which means you guys are entreated to Vicky and myself. More so Vicky, let's be honest, you know. I am looking at the chat right now. I'm seeing people in here. I'm seeing Jeremy. I'm seeing Mark, RC Maniac. We got, what do we got at the moment? 18, 22? I don't know. It depends on what the analytics say. People who are watching at this point, which is super cool. How was everybody's day one? Because, whew, a lot happened in day one. I'm trying to think, Vicky, and I was talking to Lauren about this morning. Day one saw what? Several different product releases.
Like the Cocoa Press.
Like Cocoa Press. We ended the day with Cocoa Press. We saw Brooke from PrinterBot announcing the revamp, rebirth, re-renaissance. I guess re-renaissance is repetitive, but the renaissance of PrinterBot. What else am I missing? There were others too.
Well, to be honest, yeah, the chocolate is what's foremost in my mind.
Look, I mean, recency primacy is something very real in the world of psychology. You remember the most recent thing that you saw, and you kind of remember the first thing that you saw.
And anything with chocolate.
Yes, and anything with chocolate. Absolutely. There we go. I see in the chat, Carson with the Pruser Slicer revamp. Carson, you're preaching to the choir here with the recency primacy, right? Because that was probably one of the very first things that we saw on channel 1 yesterday. So yeah, recency primacy. Yes, Michael, I am definitely killing those minutes until we get Slice involved. Thank you for the call out, because that is exactly what I am doing at this point. But you know what? That is quite all right in my mind. Good morning to you too, Gary. Looking forward to another great day. So are we. We are excited. We've got, so this morning starts off with Slice, and then from Slice we move into JWall and a video from Print That Thing around 5 tips to use in modeling. And then we got Uncle Jessy himself popping on, and followed up with Paul Paukstelis, whose name I usually butcher, and I think I got right this time, talking about 3D printing in the use of a chemistry project. I'm super excited that at 1 o'clock I'm super excited about everything, but at 1 o'clock we have a diversity panel that's going to run for an hour and be moderated. Good Lord, I can't speak this morning.
By Dr. Lawrence Nightingale.
By Dr. Lawrence Nightingale, absolutely, who was a speaker at our very first ERRF. And then we wrap up the build platform after that with AutoDrop 3D, and they're going to be talking about how to maybe use those printers that we all have to make a tad bit of revenue. So it's more than just a hobby. It's, you know, maybe revenue producing. So yeah, super excited. Carson chiming in again, saw a couple of things, 2 channels running simultaneously makes it hard to listen. Yeah, it's absolutely a lot, Carson. Not going to disagree with you about that.
Yeah, one of the new makers that I want to see is appearing like right as the diversity panel is ending. So hopefully today's channel 1 will run a little behind schedule so I can catch them both.
I don't think we have to hope, Vicky. We are already there a little bit, which is okay. There's so much to talk about. There's so much exciting stuff that people want to share, and I think that's awesome. Um, it's one of the things that I'm super excited about, and I've heard some feedback. There's so much in the 2 days, and really, Channel 1 has been packed to the brim, and ended up running over a little bit yesterday. But the really nice thing is it's all recorded. YouTube has saved everything for us, all 9 hours of the stream on Channel 1 yesterday.
And then for redundancy, we also had Zoom recorded as well. So we wanted to make sure to cover our bases to make sure that you can catch whatever you missed live.
Absolutely. With as much planning as Vicky and Chris, Lauren, Shane, and myself put into this, yeah, we were going to have those backups. We were going to have those redundancies so that we could make sure that we got everything and that we would be able to break it up. And so there's still, a little bit of work to be done around the recordings and how we're going to break those up. But yeah, those should be posted sometime in the near future. I'm very much hoping. Jeremy, I'm looking over in the chat. I'm seeing hope next year we can go in person. We'd love to have you in person next year. And I got to tell you, I want this to be in person next year as well. I don't think there's anybody on the board who doesn't. Yeah, right now we're kind of at a place where we weren't able to make that happen. And it was the right decision. I think everybody is kind of, I don't want to say everybody that reps too much in, but we've gotten a lot of feedback that it was the right decision at the right time. We're just really glad to be able to bring you guys something because we know it's a close community, and we all do like to get together. We all like to show off what we've been doing, what we've been working on, and I think this is a good opportunity to be able to do that. Vicky, I am babbling, and I am glad that you have cut in a couple of times. What do you got?
What do I got? Guys, I just want to re-emphasize the diversity panel that is going to be at 1 p.m. The Nation of Makers, I'm not going to be very articulate about this, but the Nation of Makers wrote a very powerful open letter. I'll put the link in the chat called the 3D printed elephant in the room, and how makerspaces and their attendance or their membership is actually 80% Caucasian. And so I think, there may be some uncomfortable conversations, but I think they're going to be important conversations that are going to be occurring at 1 p.m. And we have 3 PhDs that are going to be on the panel, and so five people total. And so if you can join us, I would appreciate it.
And Vicky, after that really great plug for the diversity panel we have coming up.
You want me to plug some other things?
No, I'm letting Dan from Slice into the room because Dan has wrapped up on Channel 1 and he is coming in. I see you, Dan. You able to hear us?
I can hear you. Can you hear me?
Perfect. I can hear you. I am going to let you go, sir. They are tired of hearing me talk.
All right. Got a presentation to give, so bear with me here as I share my screen. All right. Can everybody see that? Okay, I can't.
I think you are good to go, Dan.
I'm good to go. Okay, great. Yep. Thank you. Thank you for the feedback. It's hard to tell from here. All right, fantastic. Okay, so thanks everybody for tuning in to the Build platform. I have the pleasure or maybe displeasure of being the first one to go today. I get to knock it out early, but then I also, I don't get the time to see everybody else practice. So anyway, I'm Dan Barouse. I'm the CEO and co-founder of Slice Engineering. We make components for 3D printers, if you don't know who we are. And today my presentation is about making PTFE compounds safe for 3D printing. So you may have heard of issues surrounding PTFE in use in 3D printing or just PTFE in general. So I'm going to address some of those issues today and talk about them. So introduction to Slice Engineering. So our mission every day is to transform ideas into realities. So we do that by working with our customers. We try to, I think 3D printing in general is all about turning ideas into realities. It's a new way of turning something, taking something that's in your head, putting it in the computer, and then manifesting it in real life. And so our goal, our team's goal, is to try and help people make that happen better and more efficiently in ways that couldn't be done before. So that's what we do. So how we do that is we make engineering grade components for 3D printers. So myself, my co-founder, we're both mechanical engineers. My co-founder Chris is a PE, a licensed PE. So I'm not sure if that's professional engineer is the same term used globally, but essentially what it means is he can sign off on things that could be maybe detrimental or could have a detrimental effect in public safety. For example, a PE may sign off on like a bridge or something that people are driving across. You have to have a PE sign that to say this bridge is safe and people can use it, for public use. So Chris isn't a civil engineer that would sign off on a bridge, but that's the sort of the type of experience that we're bringing to the table, specifically with mechanical engineering stuff. So you may have heard of us because of our Mosquito hot end or our Copperhead hot end. Those are our two main product lines, and that's sort of what got us into the market, was making hot ends, because like I said, we're mechanical engineers, so we focus on the thermodynamics. So today my presentation is not about thermodynamics, it's actually about chemistry or polymer chemistry. So I'm not a polymer chemist, but thankfully we've got some really good resources that we can draw on, and that's why I can make this talk today. So what is PTFE? Got a little diagram here of the polymer chain, both the chemical formula and sort of a artist's rendition of what it looks like. So it's just a repeating chain, like any polymer. It's a repeating chain of the same unit over and over and over again. So that's this little N there at the bottom of the chemical formula is for. And PTFE stands for polytetrafluoroethylene. So it's a fluoropolymer, which is a slippery compound, or a group of slippery compounds that are resistant to acids, resistant to bases, and any sort of kind of solvents. So they've got a lot of different uses in industry and just in our world in general. So you may know PTFE by its trade name, which is Teflon. And there's some other trade names where PTFE is used, but Teflon is the main one that people are familiar with. And like I said, there's tons of different applications across industry. In aerospace, a major application use is in cabling, actually. So shielded cabling, PTFE is a really good dielectric, so it can be used in cables to reduce noise and provide shielding. In medical, it can be used in like medical barriers. So if you ever watch a healthcare TV show like ER or any of those shows, when they put out the sterile drapes, on the blue drapes on the tables, those are usually PTFE based. So medical, there's a ton of different uses. They also use it in implants, actually. So facial reconstruction, a lot of times they use PTFE to mold the construct, to rebuild the face, and there's tons of uses in medical for PTFE. Also for lubrication, it's used. So like I said, it's very slippery or a lubricious compound. So it can be used in all kinds of lubricants, whether that be, bearing lubricants or, in aerospace, a lot of uses for various lubricants. In consumer applications, you may have heard of the brand Gore-Tex, which is a clothing brand that has like a moisture wicking property to it. And that is also PTFE based. And then, of course, the common one that everybody is aware of, where Teflon is primarily used, is cookware. So your pans, your non-stick pans, those are all Teflon coated. And then in 3D printing, where you're probably familiar with it, is in filament guides that go into sort of traditional hot ends or PTFE lined hot ends, or Bowden tubes. Those are also made of PTFE. So since it's so useful and it's such a common compound, what's the concern, right? So if it's everywhere, why are people worried about it? So the concern is that when PTFE is heated, like most things, when they're heated, they begin to change, properties begin to change. And so when PTFE is heated above 250 degrees Celsius, the properties begin to change. And so there's safety concerns dealing with outgassing, specifically with something called volatile organic compounds. So an organic compound is just a compound that has carbon content in it. And so plastics are all organic based molecules. So they're organic compounds, carbon compounds. And when those are outgassed, when their energy level is raised to the point where the molecules start leaving the surface and turning into a vapor or a gas, they are very reactive. So that's why the volatility just in chemistry just refers to reactivity. So this is a carbon-based compound that's reactive, meaning it's going to, anything it encounters or touches, it wants to bind to. So whether that be in your lungs, on your skin, et cetera, a surface nearby, volatile organic compounds can be a problem because they bind to essentially anything they encounter. So what does this cause? A couple of the causes, or a couple of the things that can result from VOC exposure specifically with PTFE is something called polymer fume fever in humans, where you get sort of a respiratory feverish sort of cough kind of effect. And then it's also been shown to be potentially toxic and life-threatening to birds if, again, exposed in high concentration. So we want to avoid that, obviously. We don't want to hurt our birds, and you want your lungs to be good. So how do we use PTFE when this can be a problem? So I'm going to depart from talking about PTFE for a second and talk about a problem that we had with plastic adhesion. So plastic sticks to everything, as I'm sure anybody watching this probably knows. Your nozzles are dirty, your hot ends can get gummed up, there can be print failures as a result of, say, a blob gets built up on your nozzle because something stuck to it, and then into 8 hours into a 9-hour print, it gets stuck on the print and causes the whole thing to come off the bed or fail. So plastic adhesion is a huge problem, specifically on the moving portion of the 3D printer. I shamelessly stole this right-hand print failure visual from Dave Gaylord at MatterHacker's Twitter. He'd been using this hot end for a very long time, and looks like either the nozzle wasn't tight enough or something built up, and obviously had this big sort of explosion of filament sticking to the hot end. So we were seeing this problem. We print with a ton of different 3D printers with our hot ends and other people's. We do tons of different testing all the time. And so it's very important for us to figure out a solution to this problem of things sticking. So we've got this very lubricious compound that's unsafe, and then we have stuff that's sticking that we want to make not stick. What do we do about it? How do we find a way to make the PTFE compound be applied to the surface that we don't want to be sticky, but still make it safe? So we had an idea, and we came up with something called plastic repellent paint, and it is a PTFE nanosuspension. And before I go into the details of exactly what it does, I'm going to give a brief demonstration of how it works. This is a very scientific demonstration, and hope you get a lot of educational content from it. Here, Miles, somebody on our team, is illustrating what happens to your nozzle as you print plastic and it begins to adhere. Obviously a serious problem. Miles, the nozzle, is very upset over how much plastic has adhered to him. But plastic repellent paint is coming to the rescue. I'm gonna pause for dramatic effect. And now we have Miles the nozzle. He has acquired chemistry ninja powers to reflect any and all plastics. So hopefully that was very educational for everyone. All right, so what is plastic repellent paint. Like I said, it's a PTFE nano suspension. So there are nanoparticles, very, very small particles of PTFE, and they're in an aqueous solution. Aqueous just means water-based. So we've got a bunch of water with little tiny particles of PTFE in the solution. What does it do? It repels plastic from the outside of your nozzle and hop block. And it can be applied super quickly and uniformly with that little brush top that comes with the vial. It dries super fast, and it bonds to the metal very cleanly and leaves a dry, transparent coating that you can't even see, but you just know it's there because no plastic sticks to it anymore. And the key to this is that instead of the temperature that I was talking about before, 250 Celsius, we can endure printing temperatures of 290 Celsius. So significant difference in temperature capability. And I'll go into why we can do that in just a minute. So when you're looking at the different types of PTFE, there's multiple types, just like there's different types of PLA, there's different types of PETG, different grades, etc. The same thing is true of PTFE. There are different types. So we reached out to some leading polymer chemists. We found a company that was very excited, a leading chemical company that was very excited to sort of dip their foot into 3D printing, and this provided a way for them to do that. And so we worked with their principal engineers and principal chemists and found something that would work with this higher temperature rating. So that was number one thing. We found experts in the field and talked to them, figured out how do we make this work. And the main thing here was looking at what's called a long chain PTFE particle. So what you get in a Bowden tube, in a 3D printing Bowden tube setup, or a PTFE lined hot end, that type of PTFE is a shorter chain PTFE molecule. And the shorter the chain, which is that N right there in the chemical formula, or the length of the chain in the artist's rendition of what that molecule might look like, the shorter the chain, the more likely it is to outgas, because there are not as many bonds holding it together to the surface. Whereas a longer chain is going to retain itself better to the surface without providing as much option for outgassing, because the energy required to excite those molecules is going to be higher. So that's why like I mentioned, a PTFE lined hot end or a Bowden tube, you're going to start having issues around 250 Celsius. Your Teflon pan at home, DuPont has said for many years that sort of 260 was the range, and there are some studies that show that that's even less than that. But this particular setup is able to work with that longer chain up to 290 Celsius. That's what we rate it for. There's a factor of safety built in there as well, where we want to make sure that nobody exceeds that temperature when testing. And then finally, we, as any good engineer should, trust but verify, right, is the name of the game. So we worked with these leading polymer chemists. We said, yes, this is safe, this works. And then we said, all right, let's bring it in-house. Let's run a bunch of tests. Let's figure out and make sure that this really works the way we think it works, and that the chemistry is working right, that everything is safe and effective. So the test, how did we run this test? So Greg, you may see him in the Discord or in the YouTube chat. If you see him, give him a shout out. Say, hey, good job, Greg, for writing this paper. So we've got a white paper that is available for download on our website. There should be a link in the YouTube channel and in Discord to access that landing page and download the white paper. It's really interesting white paper. It's a short read, only 3 pages. So give it a shot. Again, easy read, but lots of good information packed in there. I'll sort of hit it high level in terms of not going into too many details, but just to give the overview of the test method and results. So, all right, so the goal was to determine if the total VOC outgassing level was safe. So you'll see that as TVOC, total volatile organic compounds. So the method was gravimetric analysis, which is just a fancy way to say weighing stuff before and after running a test. So we took several trays that were 5 cubic centimeters squared, and we coated them with plastic repellent paint. We chose that because we estimated the largest possible surface area of a hot block and nozzle, and then added in a factor of safety to make sure that that surface area, we were providing enough plastic repellent paint that it would be sort of a good analogy for what an user would be doing and the kind of stuff that we do in our own office. So then we cured the plastic repellent paint. We baked it for 24 hours at 209 degrees Celsius, so the upper recommended usage limit. And then between each step, we measured it on an analytical balance, a very accurate analytical balance. We calculated the total mass loss, and so that told us, how much of this PRP, the plastic repellent paint, is being outgassed, right? And then the last thing we wanted to test, and this was more so from a product usability standpoint as opposed to a safety standpoint, was does it still work after being baked for 24 hours at 290 degrees Celsius? So finally, I'll jump into the results. Before I talk too much about it, general shout out to Dave at Printed Solid. He's recently brought on these BOFA filtration units. There is a lot of VOC outgassing in general in 3D printing, a lot more than maybe we should be comfortable with when printing higher temperature plastics. When you're printing something that's like PLA, PETG, those are totally fine. But once you're getting into some higher temperature plastics, and all of our hot ends are rated to 450 degrees Celsius or 500 degrees Celsius. So we're printing sometimes with things like Peaks and Ultims, various compounds of nylons, ASAs, things that have high styrene content. There's really quite a bit more outgassing than PLA or PETG, in fact, orders of magnitude more. So that's really where you need either a fume hood, which is what we do. We put our 3D printers into a fume hood when we're testing those types of polymers, or get a filtration unit to set up in your office or lab space or work to make sure that you're creating a safe environment for yourself and whoever else is in the vicinity. So, all right, now to the results. So the way we set up sort of our pass-fail criteria was looking at OSHA, which is the Occupational Safety and Health Administration, and NIOSH, which is the National Institute of Occupational Safety and Health. Pretty sure I got that one right. We looked at their limits of what they say what a time-weighted average, meaning a long-term exposure limit, is for the types of VOCs that are being released when PTFE is heated. And we also looked at their short-term exposure. So that's like, if you're just sitting in front of the 3D printer for a little bit of time, as opposed to sitting in it with a room for, an 8-hour period. So we looked at both of those limits and then looked at how much outgassing was coming off of the PTFE, the plastic repellent paint. And we were able to show that we are between 1 and 3 orders of magnitude less than, that's the standard FFF or FDM printing. So we're 1 to 3 orders of magnitude less than the total VOCs emitted when printing PLA or PETG or ABS, things like that. We're way below those sort of normal VOC, total VOC release. And then we are significantly, again, orders of magnitude, statistically significant data below the OSHA and NIOSH limits for both time-weighted average exposure, so long-term, and short-term, brief exposures. So what that tells us is that not only is this safe, but it's safer than printing PLA, which we're obviously, since we're in this hobby, we're not particularly worried about. We do that a lot here in our office. I've got a 3D printer here running in the background, printing a PETG print. I would be comfortable having my canary in this room. I don't have a canary, but if I did, I could bring my canary in here without having too much worry about it. And this nozzle has PTFE paint on it, and so do the nozzles in our office. So we're comfortable using it. we've proven that with a study, you know, that is done according to a scientific method, and you know, that's available for anybody to download. And I would highly encourage you to check it out, read it for yourself. And then the last thing was the efficacy test. So is it still functional after being held at 290 degrees Celsius for 24 hours? And the answer is yes. We were a little surprised by this at first, but going back and speaking to those polymer chemists that I mentioned earlier, essentially what they said is that there's going to be a certain amount of the PTFE that's left on there, even after, you know, not the majority of it does not outgas, and the majority of it stays on the nozzle even after 290 degrees Celsius for an extended period of time. And that'll stay there basically indefinitely until it sort of wears off on its own or continues to break down at higher print temperatures. We're talking, you know, 350 degrees Celsius plus. So it's safe, it's effective, it works. We don't recommend using it above 290 degrees Celsius, but if you did have an application where you needed to use a higher temperature, it still will provide some protection for your nozzle, and especially if you're printing, you know, higher temperature filaments for a you know, some sort of industrial application. A print failure as a result of the nozzle running into the print can be extremely expensive and detrimental. And so highly recommend you pick some of this stuff up and try it out. We've got a sale going on this whole weekend for not only the plastic repellent paint, but everything on our website. Highly recommend you check that out. And for anybody that downloads the white paper, you will also get an email with a discount code, and an even better discount code than the general site-wide sale, specifically for the plastic repellent paint. So looks like I've got a few minutes left. So Nick, are there any questions that I can answer from either the audience or something on YouTube?
Whoop, starting up my video. It's taking a second there, Dan. I got to tell you, you guys have been on it. I've seen Max, I've seen Miles that have been in the chat. There have definitely been some people who have asked some questions, and I think Miles and Max have hit them quite quickly. As a matter of fact, I was kind of directing people, you know, send them to the Discord. I'll ask them for it.
Yeah, Discord's good.
There had originally been a question by the 3D Printing Belgian regarding, you know, if it works on, if this stuff can work on the inside of a heat break, could you make it kind of a non-stick full metal heat break that could handle hotter temperatures than the standard PTFE tubes? I mean, Max really came in, but if you want to expand on that, Dan?
Yeah, that would be the coating application. I think would be part of a limitation there. So we'd have to figure out how to coat it and cure it. It's hard to get. I guess you could maybe dunk it into a vial and then cure it on there. I mean, we have plastic repellent coatings on our heat breaks already. So this is just sort of an added bonus. And thankfully, the coating that we use on our heat breaks does not break down with temperature. It's you know, an industrial coating that lasts long term. So you know, I don't know that it's necessary for that. What I will say is we've had people use this on like silicone socks and stuff. So even if you've got a sock and you're saying, okay, well, I don't need this because I've got a sock, you know, it can be applied to a sock and used as well. So if you don't want to throw your socks away as often, you know, get some of this stuff and it can help with that. So
I got to tell you, Dan, as you were talking about this stuff, and I love the video with the nozzle and the plastic getting stuck. Yeah. I'm sure there were a number of people in this community, just like myself, who was printing kind of PPE in that March, April time period.
Yeah,
and the amount of PETG that got stuck on nozzles or on silicone socks. Yeah, this I'm definitely seeing an application for this just based on personal recent experience.
Yeah. I mean, this came out of, again, a problem that we were facing ourselves, and that's essentially how we make stuff. It's like, okay, we use 3D printers all the time, every day, and if we find an issue, that's how we solve it. So.
And there was one other question, Dan. I think you got time to answer it prior to.
Okay.
Jeremy asked in the YouTube chat, will it work on steel nozzles?
Absolutely. Yeah, it'll totally work on steel. Yeah.
Well, there we go. That is good to know as well. Dan, anything else? You still got like a minute?
Wow, look at that. Full minute. Yeah, that's it for me. I considered doing a little, Alien Josh from Alien 3D was doing the like dance compilation thing. So I was gonna do that, but yeah, I'm too tired for that. So no dancing, unfortunately.
I don't blame you. I gotta say, I have seen you guys all over Discord, all over the YouTube chats. Like, you guys have been just at it this week. And I will say we at ERRF greatly appreciate that. It's
Awesome.
always so much fun having you guys at the events and getting to chat with you guys. Glad that you guys were able to join us for the virtual event this year.
Yeah, thank you so much for putting this on, guys. I mean, it really, the year has kind of sucked for a lot of people, and having something to look forward to is a huge deal, especially as we face not just physical health issues, but like mental health stuff has been a huge concern this year. And a lot of people are just feeling down. And so having something like this where it's very positive and there's a positive energy going on, we love this kind of stuff. So thank you guys for putting it on. I know it's a ton of work to make something like this happen seamlessly. So huge shout out to you guys. We'll definitely forever be supporting ERRF and y'all's team.
Awesome. Thanks, Dan. Enjoy the rest of Sunday and some of ERRF if you're sticking around.
Yeah, for sure. Thank you.
All right. And so, because Dan has been so efficient, we're going to be able to move straight into our next presenter, who is actually not with us. Print That Thing. Jay Wall, as some may know, has sent us a video that we're going to be able to play now. That is going to give us some tips when we're talking about modeling. And so, if I can do this appropriately, I'm saying super optimistically, we are going to share my screen with this, and we're going to optimize that and share computer sound. And here we go, guys.
Hello, fellow 3D printers. I'm Jay Wall with Print That Thing, where we help you learn 3D print design. And today I'm going to be sharing with you the top 3 secrets, that's 6, the top 3 secrets that I use daily when I'm working for myself or for clients, and to help you learn 3D print design. And so I'm super stoked to be here at VERRF this year, 2020. Yeah. And very grateful to be able to talk to y'all. So let's go ahead and get started. Today I'm going to show you the 3 secrets. The first secret is going to help you keep your workflow very flexible, like you're doing some yoga designing. And then the second secret is going to keep you very efficient when you are designing. And the third one, and my favorite, is a super duper thing that I made that's going to make Blender very 3D print friendly for you. So how many people out there have tried to learn 3D print design before and maybe stopped? Or I know it can be very daunting to learn a new skill, especially 3D design. But we use 3D stuff all day. You guys are already used to 3D objects. Now we just need to learn how to control it in a program, really, and then you're off to the races. So I know personally when I first started learning 3D print design, I started and stopped at least 3 or 4 times before I really committed to learning this skill set. And now that I know it, I am on a mission to teach as many people out there as possible how to do the superpower, how to think of something from your brain, and then, wow, it amazingly just pops up on your 3D print bed. It's just creative problem solving at its finest. So that's what I want the rest of the people out there, you, to experience. And really, it just blows my mind how many people out there do not know how to 3D print their own ideas. And a lot of people out there know how to use the 3D printer, totally, but like only a small percentage actually can come up with their own ideas. It's just crazy to me. Like, it's literally half of the experience of 3D printing is being able to look at things around you and go, oh, I could fix that, or I could make that. Like, it's just very strange to me. So I'm here to help you guys and girls do that, because that's where the magic is. But enough of me blabbering. Let's go ahead and jump on in it. It's time to dive into Secret 3, where I'm going to show you the way I use Blender to keep all of my designs super flexible and quick to update. Now, imagine you have a client who can't make up their mind about the style of a design. Have you ever worked with people like that who don't know what they want? Probably yes, if you've ever worked with clients. And if you worked with clients, you're probably aware by now that most people don't know what they want until they see it, right? Well, this is where I pull out my secret weapon, the modifiers. So I'm going to show you how I take one design and make a bunch of different variations of it. So let's just take this first one here, this red one, and I'm going to just add a subdivision surface. So we just click on modifier, go subdivision surface, boom, looky there. Now we've got a smooth little monkey here. I can crank it up, make it smoother. I can turn it off. See, look at that, off and on, instant smoothation. That's what you want, super easy. But notice the bottom's a little weird and not flat, so I can just reorder the modifiers because they're super flexible, and now we've got a nice flat bottom, and that's easy for 3D printing. Now let's move on to the next one, and I'm going to add a decimate, and decimate is essentially just like low poly. It's just lowering the poly count. So look, in real time I can kind of eyeball, you know, how abstract do I want this design to be? Do I want to keep it super low poly, or do I want to be able to tell it's a monkey? Just slide that bad boy around, and there you go, on and off, instant low poly, super easy. You can do that to any model that you find online or anything you create. Next, let's go up to this blue monkey and let's remesh it. So to do that, we're kind of going to make it like 8-bit. So I'm just going to use this remesh and change it from this to blocks, and that's just going to give it kind of a blocky look. And you can just crank it up, and look at there. Now it's like got this really cool texture, and it only took like a few seconds. So that looks pretty awesome. You can again toggle it on and off to see the difference. There's before, there's after. And it looks like we did a whole bunch of work, but we didn't. We just added the modifier. So that's pretty simple. All right, now let's move on to this yellow monkey back here. And for this one, we're going to turn it into wireframe. So I'm just going to add another flexible modifier, and we'll use wireframe right here. And there you go. So right off the bat, it doesn't look that good, but what we can do is just type it in exactly the thickness we want. So maybe we want like something like 2.5 millimeters. So I just type in 2.5, and there we go. It does have some weird spikes, so we'll just uncheck this box, and there we go. It's perfect. It's ready for 3D print. And this is how I made my wireframe hat and my string rings, and it's super easy. And it looks like you did a lot of, you know, hours and hours of work, but it only took a few seconds. And now let's move on to this monkey, and we're going to do kind of some compound. So I'm going to add the wireframe just like before, but then I'm going to add the subdivision surface just like we did the first one we did, and watch what happens here. We get this really cool Voronoi look, which looks like many things you've probably seen 3D printed. It just gives it this like organic kind of 3D futuristic feel. So that's Voronoi, and it's literally just a couple modifiers, and that's it. I really like the Voronoi style, so I use that a lot. And next, let's grab the last monkey, and I'm going to show you one that I use a lot. We're going to actually turn this into a mask. So to do that, I'm going to apply this little Boolean operation here, and then go into edit mode, and then just delete the bottom of it, and just say delete. And now we've kind of got it like an open shell. So this isn't 3D printable, but with a modifier, it will magically become 3D printable. So I'm going to use solidify, and that's just going to solidify this shell here, these edges, and make it 3D printable. So now it's kind of like a mask. So if I 3D printed this really huge, I could like wear it for Halloween or something. Or, you know, you can get really creative with the solidify modifier. It does a lot of things. And there we go. And I'll kind of switch so you can see what we're looking at here, but essentially it just hollows it out. So that's a really easy, quick way to do that. And look, we've made 6 designs within a few minutes, all from one single design. So this is very, very helpful in just making super flexible, quick variations or just generating new ideas. And you can compound these modifiers all on top of themselves to get really cool effects. So yeah, it's all done from this one monkey here. And that's it for secret number 3. Did those modifiers get you thinking of some cool design ideas? I mean, in a few minutes, you just saw me make 6 variations that I can send to a client as options for them to pick from. It's a super powerful and flexible secret that's going to save you so much time. And here we are, friends, at secret number 2, where we're going to go over the secret I have in my tool belt that will help you when designing. Would you be interested in a quick and easy way to fix 3D print designs, or get informed about the exact issues within your design? Yeah. Would you be interested in a way to magically join or subtract 3D objects together and be able to adjust them in real time? And that, my friends, is something that can be done with just a few awesome Blender add-ons. Blender add-ons are powerful extensions made by Blender and the Blender community that you can turn on to make the software more robust and really help you with your workflows depending on what you're trying to do. Now, Blender comes with a bunch of add-ons that you can opt in and use straight from inside the software, but the ones that I use all the time here at Print That Thing are the 3D Print Toolbox and the Bool tool. Let me show you some things. The 3D Print Toolbox will let you know the volume, so it'll give you the cubic centimeters. It'll give you the area of your model here, whatever you have selected. You can do solid, which checks if it's manifold or watertight. So that means, if it's 3D printable. So I can go to edit mode, click, is this solid? And it'll say there's some holes right here. So I can say, oh, okay, the eyes are highlighted. I can also look for intersections. Blender will tell me if there's any geometry that's like mashing into each other. So lots of issues around the eyes here. So thank you 3D Print Toolbox for helping me out. And then we can do degenerate, which there's none here. We can do distorted. So if we select that, the toolbox will tell us which ones are distorted. So all those that are lit up, it's kind of hard to see, but the ones around the nose and kind of around the ears, all those are getting stretched way too far. So Blender's just kind of letting us know that. We can also look for the thickness, which is saying the eyeball here is a little too thin, or it's not thick enough. We could also do if there's some sharp edges, or what's really cool is the overhangs. So that's where you would need support material all up underneath Suzanne here. It would just be kind of hovering, so that's pretty cool. But you can also use the 3D Print Toolbox for cleanup or export it. So let's make this 3D printable. I'm going to start by just selecting the eye here and this eye, and then popping them out with the selection and renaming the eyes. And let's just work on the Suzanne. So I'm going to turn the eyes off. And looky there's big holes in Suzanne's head. We can use the 3D Print Toolbox to help find it. Let me just do non-manifold, and it's highlighting those. And what's cool is you can just hit make manifold, and boom, there it goes. It's fixed. Now it's 3D printable. So that's with the 3D Print Toolbox. Now if I hit check all, notice it's zeroed out there, but our non-flat faces is still 22. So there's our 22 faces that are messed up. But what's cool is I can use the 3D Print Toolbox to fix those as well. So watch, if I just click this cleanup distorted, bloop, all those have been triangulated. And now if I check all, that's zeroed out too. That's what you want. You want zeros for everything. And then we still have our overhanging faces, but I'm going to show you how to fix that after our eyes here. So let's just go back to object mode, turn our eyes back on, maybe turn Suzanne off, and let's inspect our eyes. So we're going to use the 3D Print Toolbox to inspect the eyes. So if we do check all, non-manifold, there it is. It's saying these outer rings right here are just big holes. So what we're going to do is just select them and say make manifold. Boom, fixed. Thank you 3D Print Toolbox. And now if we check all, it's zeroed out, which is good, but we still have 2 thin faces. So if we click on that, it'll just tell me exactly what the issue is. It's these 2 polygons that are too thin. So I'm just going to kind of make it less steep. So to do that, I'm just going to grab the top little area here. So just grab that little line right there, and I'm just going to grab it and bring it down just a little bit, hit check all, and there we go. Everything's zeroed out. And we don't have to worry about our overhanging faces because these are just eyes. So let's turn on that. But they're still technically 2 separate objects. So that's when the Bool tool comes into play. So now let's go to the Bool tool here. And we're going to do a brush Boolean union. So click on the eyes, click right there. Click on the eyes, click on the head, and then union. Boom. Just like that, we've magically created this to be a solid object. But what's cool is that they're still flexible. Like if it applied and made the eyes combined with the head. But if I go into my modifiers here, you can see that it just added a Boolean union for the eyes, but it didn't apply it. So I can always go back and change that on the fly anytime I want. And that's what I mean by keeping you flexible. Now let's make this where we don't need supports. So I'm just going to turn the Suzanne sideways, add a big cube, and then just bring it on down. And we're going to use the other part of the bool tool, which is the subtraction or the difference. So I'm just going to click on the big white cube here that we just added, and then shift click on the head and then do a difference. Boom, just like that. So you can see that the cube turned into a wireframe, and the benefit of this is I can just grab it and cut it up in real time and see, you know, exactly where I want to slice it. So that's pretty awesome, and I use that all the time. And notice we've got two modifiers. We can export this out. Just tell the 3D print toolbox where we want it to go. I'll just do the desktop, and then we'll just hit export, and there we go. That's all we have to do to make to fix an object or to make it print without supports. And now I'm going to bring it into Prusa Slicer. And there's our monkey ready to be 3D printed. Let's slice it up. So looky there, within a few minutes we fixed a file, added objects together, subtracted objects to flatten it out, and it is going to be a perfect 3D print. So that's pretty awesome. And I could go on and on and on and on about add-ons, but for the sake of time in this seminar, I'm going to stop here because the bool tool and the 3D print toolbox are the ones I use the most. Now, we've covered secret number 3, the use of flexible modifiers. Secret number 2, the power of add-ons like the bool tool and 3D print toolbox. Are you ready to learn about my number 1 Blender secret for 3D print design? Now, secret number 1 involves a little bit of a personal hack that I made for myself and students that I'm very excited to share with you in this seminar. And that is our Blender hack for 3D printing starter file. You're going to get this starter file for free today at the end, so let me show you how it works. Now imagine you've designed something that requires specific measurements, like to the nth degree, and you put in all this work, but then you go to print it and it's too big for your 3D print bed. I've done this many times. So this print file is actually going to show you visually your build dimensions of your 3D printer, so you can always have a reference while you're designing things. So when you first open up Blender, it'll look just like this. You'll have a big cube in the middle, and the dimensions are actually set for meters. So if I have the cube selected, notice it's 2 meters, which is 2,000 millimeters. We could switch it, but instead just open up the file we gave you. Just do File, Open, find the file, click Open, and there you go. Now you're set up. It's all in millimeters. You've got your little monkey here, and notice right here to the side, it's all in millimeters. And there you go. So that's about 15 steps done for you. Also, we have some tabs over here, but I want you to take note of this 3D print volume. And you get to it by twiddling down 3D printer, and then just double click on this and then type in your printer name. So I'm using the CR10, and you can add volume to the end if it helps. And then just go to your information tab right here under item. And if you can't see it, you can just hit N on your keyboard, and then just type in the dimensions of your build volume. So if you have a small printer, you can do 100, 100 by 100, and that'll get you, it'll let you know how big you have to design. But luckily I have a CR10, so I'm just gonna undo that and keep it pretty huge. Imagine you have a client who wants to see a product shot, or you just want a cool shot of your design for social media before it's 3D printed. Well, this hack file can help you with that too. So I've brought in this new design I'm working on. It's called Benchy in a Bottle. And the Benchy is courtesy of Creative Tools. So thanks, Creative Tools. But essentially, I just wanted to make a benchmark to go around the benchmark Benchy. But let's take a photo of this. So we're going to go over to Studio and then twiddle it down. And we've got our lights. I've got you a camera set up. And we've got this cool background. So all we got to do is turn the background on. And looky there. We've got a nice studio background that we can take photos of. So we'll just zoom in, and then all you have to do to get a camera view is just hit 0 on your numpad, and now we're inside of our camera looking at the thing. And I've already set it all up for you. All you have to do to take a picture is just do render and render image. That's it. And now you have an image that you can send to a client. Just go ahead and do save as and name it anything you want. I'm just going to call it Benchy Photo. And there we go. But it gets way cooler than this. Now let's say we wanted to take a 360 product shot and send it to a client or just post it on our socials. This is how you do it. We'll just click on the Benchy and then take our 360 controller, just grab the object, hold shift, and drop it onto the 360 controller. Now when we hit play, bada bing, bada boom. Now we've got an instant 360 product shot. But it gets cooler than this. Say we wanted to change the colors. So we can go to our colors tab and then just click on the colors and just update these colors in real time so we can kind of previs, what color we want to print this, what color we want to, we can even change the boat. We can do, blue. Maybe we want to change the color of the cork. We can do maybe a green or a blue, who knows, it's totally up to you. But this just gets the ideas flowing. And, maybe we want to change the background color. So I can just click on the background, add a color for that. And maybe we'll do like a light blue, kind of like they're out to sea. Or, that looks pretty good, I guess. But really it's just getting the ideas flowing, get your mind creativity juices going. But I really like this white bottle here. Maybe make the cork a little more yellow, maybe a little like a darker yellow. That looks pretty cool. And maybe for the background, let's change the background. Maybe it's not so just dark blue on blue. Let's do like blue on yellow. Yeah, that looks pretty crazy, pretty wild. So I'm digging that. Not only that, you can mess with the lights. So you can go to your lights and you can turn off lights. You can get side lighting, or really anything you want to do. Or you can increase the brightness, but everything's already set up for you. And so really all you have to do is just play around and click things until you like it. And then once you're kind of ready for that, you can go to your tab here and just click movie and then go to render animation, and Blender will do the rest for you. And it will just render out every single frame, and there you go. Then you can send that movie over to a client, or post it online, or do anything you want with it. But it looks pretty awesome if you ask me.
And the best part about our #1 secret is that you get to download this and have it today. Just go to VERRF.ptt.live and download it. And if you need a little bit extra help, or if you need help just learning or getting to know the kind of the backbone of Blender, then you can take my free beginner 100 course today, get going and set up your printer for 3D print design. It's going to be crazy. It'll totally change your whole mindset of and how you see the world around you. But yeah, thank you, Ver, for having me today. Thanks everybody for watching, and hope you have a great day and keep creating. Peace.
All right, guys. I have been watching the chat on my second screen. And I saw that feedback that there were some issues regarding the video and audio quality and so on and so forth. Oh, I'm going to stop looking like a DJ and actually put the headset back on. I do apologize for that. I will reach out to JWall and see if maybe he will let us put it as a video on the build platform stage, or the build platform channel. If he's willing to do that, then I will make sure to get it on the Discord, and I'm sure we can probably announce it via the website and via our various social media channels as well. So I do apologize if the video was glitchy or the audio sounded glitchy and there were hiccups there. It probably doesn't help you all, but it sounded amazing on my end, and I came away from the video feeling so much more informed, even though I have absolutely no skill when it comes to modeling. So I am sorry about that. Vicky, I saw you kind of move forward.
No, yeah, just apologies for the audio, but hopefully you can catch that he has great energy and great passion for 3D printing and 3D modeling, and he's very generous with his knowledge and wanting to lift you up to achieve your designs. So hopefully we can get that video to you. And I know I personally took his Blender 2.8 class, and I rather enjoyed it. And I think some of the people in the chat were mentioning that too.
Yeah, I am sorry about that. He sent the video, and in hindsight, it probably should have been an unlisted video on YouTube and then been able to stream it off of there. I think that's where we've seen some success with videos on some of our other channels, or our other channel on, and when people on channel 1 have been using it. So yes, apologies for that, guys. I say guys, I'm using the, I apologize for using the term guys. I say it a lot. I'm trying to move away from it, but all right. Yes, I do. I'm looking over in the chat right now. Okay, it looks like some have done non-YouTube. I'm seeing, yes, that the energy is definitely infectious. Glad he isn't selling cookies. Oh man, selling cookies would be a little bit of an issue. I would buy cookies all day. Kind of energy. Not that I wouldn't buy cookies all day anyway, but yeah. So again, sorry about that. I will reach out to J-Wall and see if he's okay with us putting it on the Build Platform website. And if he is, I will make sure to do that. Apologize about apologizing. Look, RC Maniac, for those who don't know, I have a very Franco-American Canadian background, so that just falls in really deeply with who I am. Lots of apologies. So yeah, just falling back on heritage there. I think that's a big issue, or a big part of it. Excellent. All right. I'm looking at the time. We have got just about 4 minutes before we're supposed to start our next speaker. But I do see that our next speaker is actually in the waiting room at this point. I am going to surprise him a little bit and bring him in early. Let me see. Hold on, as the one, the only. Vicky, did you have something?
I had them flip-flopped in my head, so I thought you pulled the wrong one, but you're on it.
Oh, I know. And I'm seeing, oh, that awesome helmet. I love that awesome helmet in his in the picture. So I started with the one, the only, the
There we go.
amazing Clayton. There he is.
Oh no, my audio is not coming through my headsets here. Hopefully this will sound okay.
We are hearing you just fine, and I know that I brought you on a little bit early, so if you want to spend 3 minutes fixing your audio, I will just babble nonstop.
That's perfect. I'm sorting out some technical difficulties as well with the iPad here, as I was wanting to show off some cool 3D design stuff for your mobile devices. But yes, yeah, feel free to babble as I'm making sure this is working correctly.
It is one of those things that I feel I am greatest at, just the nonstop incessant chatter. So
awesome job, by the way, you guys. Today and yesterday has been absolutely wonderful for all the sessions I've sat in on.
I gotta say it's, you know, we've said this before. I'm gonna say it again, and there's a possibility that somebody in the chat is gonna call me on being apologetic or over whatever, but it's you guys, it's the community, it's the sponsors who have been willing to kind of jump in and do this. It's the exhibitors, it's the presenters, it's everybody who's been able to come together and show off all this awesome stuff that they've been working on, you know, throughout the course of the last year, you know, with maybe one or two other things going on for certain periods of time. But it's just been phenomenal, to the response that we've gotten from everybody. I'm super excited that we've been able to do this and have as many great people be as part of it as possible. So I am in awe, and will forever be grateful to all the members of the community who are making this what it is.
That's amazing.
I mean, I can keep going with another 2 minutes of
No,
platitudes
no, no,
if
no,
you
no.
want, or you're good to go. So
I think I'm good to go. I think I'm good to go. I'll just have to screen share, and then that's it. So
awesome, Clayton. I'm gonna give it to you. I'm gonna turn my mic off and I'm gonna stop babbling.
Yeah, perfect. So hi everybody. My name's Uncle Jesse. I run a mostly 3D printing YouTube channel, mostly around cosplay, making all sorts of fun stuff there. Heavy into resin 3D printers. I feel bad for Nick. Sorry. I gave him like a few suggestions on topics I wanted to talk about, and it's not going to be on 3D printers or resin 3D printers, which I was thinking I was going to do. I really want to talk with you guys about the ability for you to now do mobile design work very easily, really straightforward design work on mobile devices. And there is, over the last handful of years, some amazing tech that has come out. I've been spending a lot of time playing around with those. I am not a 3D designer, modeler by trade, or know any really skilled at it by any means whatsoever. I just enjoy playing around with these things. And so what today I wanted to show you is one of the newest apps that's available on both Android and iOS devices, called Nomad. Not sponsored by them or anything like that. Just really enjoy the app. And funny enough, I was on a session, sitting in and watching a session earlier today, and I think it was Toy Maker 3D was showing off some 3D printed action figures that they make, and the files that they sell, which it looked like were all designed on Shaper 3D, which is an iPad Fusion 360 type application. It's really wild to see how much these apps are evolving over the years and more intuitive they're becoming. But basically, let me cut over to my iPad. Let me share my screen here with this. I just need to plug in my code. And apologies, had some technical difficulties getting this all up and running, and hopefully I can get this. Need the screen share. Screen share. There we go. And share. Okay, so you guys are hopefully seeing my Nick, if you can just let me know if you guys are seeing my screen. Hopefully you're seeing an iPad screen here. Installed something very last minute to get this to work.
You're good.
Perfect. Was not cooperating with Zoom when I was trying this out. So the app today that I'm going to be really talking to you guys about is this Nomad sculpting app. Again, available for Android and iOS devices. This is actually a 3D scan of my head that I used also from a mobile device using my iPhone, called Scandy Pro. I did a video on this, I think a year plus ago, about how you can 3D scan different, body parts, your head, your arms, your legs, whatever it may be, for references when it comes to actually making cosplay items. So this was a head scan that I did. I ended up cleaning it up, smoothing it out, cleaned out the beard, chopped off all of the hair to give me a much cleaner, application to work with. This is all, I'm running this on an iPad, but again, is available on an Android as well. You've got really basic and intuitive functions here, where on the left-hand side, you've got things like what's the brush size that you want to work with, the intensity, if you want symmetry on or off. Here on the right-hand side are all of your different brushes that you might be able to work with. So if you wanted a clay brush, or just a regular brush, or a move tool, or if I wanted to, make my forehead extra large, which it's already too large as it is. It's got gesture controls built into this as well. So here, I'm going to turn off autosave here for the second. So if I wanted to double tap with 2 fingers on the screen, it will undo. If I use 3 fingers, it will redo the changes that I've just made. So if you've ever used an app called Procreate, which is a design app, it's very similar to that. But what I wanted to do, something just really fun with you guys with this, just to kind of show off what you can do with this app, is, since it's semi-Halloween season here, what I wanted to do is just quickly make a face mask and show that off to you guys. So here I'm going to come in and use the mask tool, which I can come in and then adjust here, but this will allow me to make a selection on my 3D avatar here of my head, and I can select whatever I would want to select here with this with this masking tool. Typically what you'll use this for is if I wanted to go in and sculpt some other area of the head and not affect any of the selected area, that's what that mask tool will do. But whoops, there we go. But what we want to use this for is a way to actually make a selection on my face so that we can turn this into a mask. And what I'm going to do is just clean up my mask a little bit here. Maybe I'll take out, oops, I'm not using the right tool. I'm going to come in and unmask my eyes because we want an opening here where my eyes are. I'm just going to try and clean this up slightly. I also want one for the mouth here. I'm not too concerned over how accurate I'm being with this. I'm going to try my best to clean it up and give it a little bit of stylized look here. I don't want it to be a smiley face there. So it's looking a little odd here, but we could also do some weird things like I could come in and add some, I don't know, some lines here or maybe over here. And then what we're going to end up doing is coming up into one of the mask menus. This is the settings that controls basically when you're masking, how sharp it is or how blurry it might be, the intensity of it. But it also has some really cool tools in here like extracting. And what we want to do is take what we've masked out here, and I'm going to adjust the thickness and the smoothness of it after it's extracted, and click extract. And it's now very quickly created everything that I've just selected there. It's extracted it from this head, and very quickly it's created a mask for me to start working with. So now I can go in from here and start further refining or adding on to this. And with the whole point of I want to be able to make a mask that I can wear that's going to fit my head, that I can use for a 3D printer or for Halloween. And it's just a really cool way to very easily come in and do something like this without knowing ZBrush or Fusion 360 or any of these other really complex tools. This is super, super straightforward and really easy to use and jump into, but also has a lot of depth to it as well in terms of the functionality. So there's a lot of things that you can do with this that I wouldn't expect from an iPad or tablet app. And this app specifically is also available on your phone as well. So I think on both iPhones and Android phones, you can download this. I believe it's 14 or 15 bucks for the app, which isn't too bad considering the price of ZBrush, which is a few $100s just for the subscription. So from here, I can further refine this. Like I said, I can add more, more details, more callouts to it if I wanted to add other fun stuff to it. And then eventually what we want to be able to get to is coming over here in the folder menu section. I can export this as an OBJ file or an STL file with, again, the intention of me bringing this to a 3D printer. So again, I just made this real quick with you guys here in a matter of seconds. I did want to show something that I put together this morning while I was watching another session and literally spent, I don't know, 15 minutes working on it. So not that much time whatsoever. It's very similar mask, nothing super crazy. Again, just 10, 15 minutes playing around in the app. And it's going to allow you to very quickly get in and build something, even if you have literally no design skills whatsoever. And it's a really quick and easy way for you to make a replica prop here. So this is something that I'm going to be using and showing off in some upcoming videos here soon. And I'm looking forward to making my own masks and props here with a tool just like this here today. That's basically all I wanted to cover with you guys and share, just because I thought it was cool and figure if I thought it was cool, some of you might think it's cool as well. And then let me stop sharing my screen.
Dude, I'm just gonna jump in with awesome.
It's pretty, I mean, that was literally 5 minutes that I made a mask there real quick. So
that is amazing. I'm looking at the YouTube chat right now, and first off, people weren't really sure about, hadn't heard about the app again. So I got somebody asking, what's the name of the app again, Clayton?
Yeah, it's Nomad. It's called Nomad app or Nomad 3D. They're also on the Twitters as well. It literally, so I put out a video about a month or so ago about like the best 3D printing or excuse me, the best design apps for 3D design apps for the iPad. And this literally came out, I think, 1 week later. And I was like, oh my God, this blows away everything else that's out there. And the guy that's made it has also been just cranking out updates and listening to the community of feedback and new features. It's basically, I think about every 2 weeks, there's a new update to the app with new fixes and features, which is pretty cool.
I think the overwhelming thing that I've seen in the chat so far is, this is crazy, to which I obviously had to respond, crazy awesome. But, we're getting Geeky Faye commenting that, this is fantastic for just a bit of playing around in talking about the best that you did just in 5 minutes.
Yep.
I think you've motivated.
Yeah, I mean,
oh, go ahead.
No, I mean, that's the whole, I mean, for me, it was, I have ZBrush, I have a subscription to ZBrush, and it's a bit overwhelming. And this is just really straightforward, and it's less it's less of a challenge for me to jump in there. And like I said, I can make a cup of coffee and spend 10 minutes just monkeying around with the design, and then go on with my day. And maybe I'll come back at the end of the day and do some more work on it. Just fun.
Yeah, I mean, there's a couple of people who have mentioned, need to get into modeling and doing some of that now. Again, myself included, who has done nothing in the modeling world, but seeing, and this is not to denigrate your skill at all. I mean, dude, you're amazing.
No. It's, I have no idea. No idea what I'm doing, like any percent of the time. So
I am right there with you. As a matter of fact, what might be interesting now that I'm thinking about this, Clayton? We just start like a YouTube where we name it, we have no idea what we're doing 90% of the time, and then just mess around with these things.
Just mess around with them.
right.
That's exactly right. That's perfect. I was gonna say, so, and then what was wild to me is, so the other one, so this is really, Nomad is really, the focus is how can you build a tool that more or less does what ZBrush does, maybe not to the full extent, but on a tablet, which is crazy. And then Shaper 3D, which is free to try, but has a subscription behind it. And it is, I think it's like $20 a month. It's a good bit more expensive, but it really does. To me, I've used that one as well. It's a lot more intuitive than Fusion 360. It's really, really straightforward, especially with using like an Apple Pencil or a stylus with any of these apps. Just makes it a lot easier, especially including with the gesture controls, being able to use your hands to move around in a 3D space. It just seems a lot easier than using a mouse to navigate. And it's always been kind of awkward for me using those other design tools on a computer versus using my hands to be able to touch and pull and zoom in and zoom out, or double tap to undo type thing.
Yeah, and you've got people in the chat talking about ZBrush having such an incredibly steep learning curve, and how if it is something you feel comfortable with, you can take what you're doing in Nomad and then export it to ZBrush for more detail.
Oh yeah, 100%. Yeah, no, I've seen a few. There's been a few makers out there on YouTube. If you go up, there's some really incredible tutorials already on the app, and exactly that. They've taken what they've basically done on the bus in Nomad or whatever it is that they are at, and go into ZBrush afterwards to further refine it. It's
absolutely
cool.
Yeah, super cool. Thanks. I do have one more. There was a comment in the chat that I think I really needed to get to. It wasn't so much a comment. It was a comment. It wasn't a question. Just that hair. Coming obviously from Repcord. I mean, who I think is kind of jealous because he has heat miser hair.
It's the coif, it's the, you got to keep it. I had to make sure the hair was on point this morning before jumping on with you guys.
Second thought, I don't know if he's talking about your hair or mine. So I might.
It's probably yours.
It's a good. I feel like it's a good look most of the time. It has.
Hey, unrelated to everybody else that might be listening, when we gonna jump back on, do some more PUBGs or Apex Legends or?
I will tell you what. As soon as we wrap up, I am definitely missing my Xbox time. So I will be on later this afternoon, later this evening. So I'm definitely up for some PUBG.
Yeah, forget about finding me on YouTube. Find me on Xbox at Uncle Jessy if anybody wants to play games.
All right, bud. You good?
Awesome. I'm good. That's it. Just want to say hi and share that with you guys. I thought that was fun. Hopefully some folks out there thought it was fun and interesting. I don't know.
Based on what I'm seeing in the comments, absolutely. So
Awesome. Hey, keep up
Excellent.
the awesome work, you guys. Looking forward to the rest of the presenters today.
cool. We'll catch up with you soon, bud.
All right. Thanks. All right. Bye now.
All right, and we're moving right through the swing of things, folks. As Clayton is heading out, I am working to admit our next speaker, Mr. Paul. Paul, you're gonna have to help me out because I feel like I kill your last name every time I say it. I want to say Paukstelis. Is that right?
You nailed it. You nailed it.
Yes, I'm gonna take the moral victory. I am also gonna turn it over to you, good sir.
Okay, let me get started with some screen sharing here, starting with getting this full screen. And let me, so I'm gonna do a video and hopefully this works. And I just want to say thank you very much to the organizers for putting everything together. It's been great. And I'm watching the chat, so if you have questions in the YouTube chat while this video plays, and it'll be self-explanatory why I had to do a video, I think. But yeah. Let me know if this works.
I am seeing the video up, Paul, but I'm not hearing the audio come through on it.
No audio?
Nope.
Oh, that's, yeah, my fault. Let me go back. And I did not share with audio. That is my fault. Let me stop share for a moment. Share computer sound.
The prospects of Hurricane Delta and its remnants rolling through on Sunday means that I'm going to have to pre-record this video for you.
Perfect.
And I'm
Paul.
coming to you today from the campus of the University of Maryland, and I'm outside the Chemistry Complex atrium to share with you a project that we're calling Chemistry in Our Garden. This is an educational project that merges chemistry, botany, art, and of course 3D printing. And the ultimate goal of this project is to give those that use and share this space a greater appreciation for the chemistry that's around them every day. My collaborators on this project are Jeff Davis and Andrea Otteson. Jeff is an organic chemist, and Andrea is a plant scientist and artist, and she does some really amazing things integrating science and art, and you can check out her website here. This project arose out of an idea Jeff had for one of his organic chemistry courses. He wanted his students to take a little different approach to advanced organic chemistry. And instead of going through and memorizing a bunch of equations and reactions, as a lot of you who've taken organic chemistry know what I'm talking about, Jeff had them working on natural products. And these are chemical compounds that are isolated directly from the environment. And because we're talking about organic molecules, these usually come from living things. And many of the natural products that we encounter in our everyday lives come from plants. This includes the PLA that many of you are probably melting in your printer right now. And even the terephthalate that is in your PETG was first characterized from extracts of the turpentine tree. Now, many natural products are also medicinal compounds, and we usually hear about these in terms of being used by indigenous peoples. And that spawned a whole field of something called ethnobotany. And it provides an important way for identifying and developing new pharmaceuticals. But plants with these medicinal compounds aren't just in, say, the Amazon rainforest. They're all around us. Having this great courtyard and garden right outside our building provided the perfect backdrop for this project. Jeff and Andrea identified all the plants that are around here, and they began brainstorming for ways to share the chemistry side with the hundreds of people that walk through this courtyard daily, at least when classes are held in person. When they hit on the idea of creating molecular sculptures of these natural products, they contacted me, and we had 3D printing in the mix. The concept behind the class was that the students would identify plants in and around the building and research any interesting or medically related compounds that might be found in those plants. We would then 3D print these and display them next to the plant. This project really started in early March, and as you might expect, we were thrown off quite a bit by the pandemic. But if you'll take a quick stroll with me through the garden, I'll show you a few of the examples of things that we put together and describe where we hope this project will go. And at the end, I'll dive more into some of the challenges that come with the 3D printing of molecular structures. So come on, let's take a walk. Well, I hope I don't make anybody too seasick as I'm going into handheld mode here. But the first molecule that we're going to encounter on our stroll here is one called betulinic acid. Now, this is a compound that's found in high concentrations of the bark of birch trees, like this river birch here. And something like 25% by weight of this birch bark is composed of betulinic acid. Now, this is a medicinal compound, so betulinic acid, as it's shown right here, here's our 3D printed model, has been shown to slow the growth of human melanoma cells. And so this is an anti-cancer agent. And also, if you make some modifications of this oxygen just right here, this becomes a potent inhibitor of HIV replication. Now, see, we've also done a few signs here for our display. And we haven't done this for all our molecules yet, but we've created these to help identify the plant, to show the molecular formula of or the chemical formula of the compound, and it has this QR code as well that takes you to the website where you can learn more about each molecule. And the idea is that this provides a unique way that you can interact both physically with the 3D printed molecule and then virtually on the website. All right, let's continue along, and I'll just show you a couple more plants and a couple more things that we printed. So the next molecule that we're going to encounter right here is cyanidin. Now, cyanidin is a pH indicator, and it's also the base molecule that's responsible for many of the bright colors that you see in fruits and vegetables. And here we're looking at the winterberry plant, and it's the cyanidin that's responsible for the bright red color of these berries. Now, the color of cyanidin, as I mentioned, it's a pH indicator, so it changes from blue to red based on the pH and other environments that it's in. And it's one of the reasons why you have blueberries that are blue, and things like beets and red cabbages have their red and purple color. And it's also an antioxidant, so when people tell you to eat your blueberries because they're high in antioxidants, it's coming from this cyanidin molecule. We'll look at just one more plant and molecule, and it's right over here. And this is a really very striking plant. So this is the beautyberry, and you can see that it has these amazing purple berries on it. And there are a number of interesting molecules that have been isolated from beautyberry, and one of these is this guy right here. This is spathulinol. Here's the 3D printed molecule right up here. And spathulinol has actually been approved as a natural mosquito repellent. So if you plant a bunch of beautyberry right here, you get this striking looking plant with these crazy purple berries, and also keep the mosquitoes away. So not all of the plants for which we've made molecules for are still out. So some of them obviously come out in spring and are gone. So one of the things that we've done is for those molecules, we've have them in this space right here. So we've plan on in the winter months as well, displaying these along with other molecules that have been 3D printed as part of the educational program in the Department of Chemistry and Biochemistry at the University of Maryland. These are a couple of our plant compounds. This is narcyclacine from daffodils and berberine from the barberry plant. So we've just spun everything back up with this project after being down for quite a while. And we now have 4 undergraduates. We have Fiona, Rebecca, Joshua, and Lucas that are continuing the process of cataloging, researching, and ultimately they're going to do the 3D printing of many of the molecules in our garden as possible. Now, one of the important goals of this project is also giving back. So one of the things that we are intending on doing is setting up a repository for both the information about the molecules as well as the 3D models themselves, so that if you're interested in doing something similar in your garden or in your local park, you can download these models and get started. It doesn't have to be just chemistry in our garden, it can be chemistry in your garden. We hope this project, using 3D printed sculptures, can help open up and expand the appreciation of some of the amazing things that we walk past every day. Now I'm going to transition a bit and talk a little bit about some of the challenges that I've run into when it comes to 3D printing molecular structures, and also some of the tools that I've developed to overcome these.
So there are a number of challenges when it comes to 3D printing molecular models. And the first one that you run into is that when you're printing something that has a complex 3D geometry, the number of supports that you need scales with that complexity. So this isn't a huge problem with the garden project because those molecules are fairly simple. But if you're trying to print something like this DNA double helix here, you have to use tons and tons of supports in order to do this. And I'll point out that I don't actually use this slicer. I just want everyone to know that, but it's nice to be able to show the supports like this. Now, the other problem that you run into is that of scale and volume. If you take the example of bitulinic acid that I gave you, we wanted to print that at a very large scale, but we're limited by the volume of 3D printers. So, you can only print it so large if your printer will only print a certain size. So the way that we can actually overcome both of these issues is by reducing molecular complexity. So if we take a complex molecule in 3-dimensional space and now split it up into individual pieces, so this is an ATP molecule where we split it up into 3 independent pieces where you now have a pin down here and you have a hole in this atom where that pin fits into, you can arrange these on the build plate so that you need just minimal supports to be able to print this, and then you can assemble it after the fact. And it's much faster, saves material, and works really well. So in order to do this, I developed an add-on for Blender called MolePrint 3D. And this is a Blender 2.7 add-on, and before you ask, I have updated to work with Blender 2.8, but it turns out that they removed the carve solver from Blender 2.8, and there are certain things that just work a lot better with the carve solver, so I've stuck with Blender 2.7 at this point. And the idea behind this is that this provides you an interactive way of splitting up these molecular models into smaller pieces where it'll automatically create the pins in the bonds and holes in the atoms so that you can assemble this after they've been printed. And it does a number of things, including automated model orientation, so getting your models arranged on the bed, and then also it'll do multicolor output, so you can do MMU or palette style prints. And you can get the add-on down here, and you can read more about it in a publication that I did a couple years ago already for this. And I'll just show you some examples of things that you can do with this. This isn't related to the garden project, but you can do very complex 3D prints when you're splitting things up into pieces, and you're just really limited now by assembly time. So I'm just going to run through and just show you very basically how this add-on in Blender works. Okay, so this is the MolePrint 3D tool interface that you use for doing this, and we input VRML files or X3D files, and these can be output by pretty much all of the molecular visualization software that's out there these days. And I'll just zoom in on this, and this is the spethulinol that I showed you earlier. And the thing that makes this work is that the VRML 2 format uses primitives, so you have spheres and cylinders, and we know in this case that all of the atoms are going to be spheres, and we know all of the cylinders are going to be bonds, so that's one of the principles that it uses for working with this. And we do things like clean up the scene here. We can do things like add in this, for example, should be a double bond, so we can convert that into a double bond. And then we build our interaction list so it knows which cylinders and which spheres are touching each other. So we set that up, and now what we can do is start splitting this molecule up into different pieces. So as soon as we start clicking, it changes color to indicate how many different groups that we're going to have. And for this example, let's say I'll set up these and one more. And so now what we would have is 2 different groups. So this would be, and every place where there's a junction, it's going to put a pin. So we could do this in a whole variety of different ways, right? We could set this up to do something like this, just depending on how we wanted to print it. And it's nice to be able to have this be interactive. And just to give you an idea, you can set some of the different features. So you can set, you know, the relative size of the pins and how much play that you're going to have for the pins, etc. And you can even do things like split pins. So I won't bother showing you that, but there's a number of different features that go into this. And then we just do this set pin group and then click pin and join. And what it'll do now is it'll split this up into 2 objects. Here's one where it has our pins, and then we have our other one here, as you can see, that has the holes. And now we can get this into a decent orientation on the build plate if we just click floor all here. And now if we look at the direction relative to the build plate, Z is blue here, so Z is up. So this just uses convex hull method to look for the largest surface area to put down onto the build plate. And that's really all it does, but you can do complex things. You can make every single atom and every single bond its own individual object, basically just a little molecular model kit, which is kind of what we've done with some of the bigger things in the Garden project. And so this is something that I very sort of seldomly update it now because it's gotten to a functional state, but I'm still looking for new features to put into this. And it
Okay, that's about it. Yeah, so I don't know if anybody has any questions.
I will say, Paul, I'm just going to jump in quickly. I think Vicky's done a great job answering questions in the chat, as have you, as you've been watching it. But I think the big takeaway that I got from watching people's chat and the presentation itself is you have inspired some people to do some new things in their garden this upcoming year. I will say for Vicky and myself, I think this is going to become a new thing for us to do also. So in the world of education, I don't think there's more you can ask than to inspire and educate people. And I think you have done that, sir.
Excellent. Well, thank you very much. I mean, obviously that is what we try to do as educators. And I will say that the other good thing about the video is that being a university professor is that if you just let us start talking, we don't stop. So, you know, I cut it right at 15 minutes. So
Perfect.
Gonna say YouTube people do the same thing, apparently. But awesome, Paul. Thanks for bringing that on. That really was amazing. And I have some idea that I'm going to be delving back into some educational stuff here for my garden in the upcoming year when, you know, there isn't snow on the ground.
Fantastic. And thanks again, everyone, for organizing this and letting us have this opportunity to talk about the things that we're doing.
Oh, excellent. All right, as we keep things moving, I am going to bring in everybody that we've got in the waiting room, which is going to start up our diversity panel. And while I know I'm very excited about this, Vicky, I know this is something that you have been hugely excited about as well.
Oh, yes. And they're still coming, huh? Yeah, thank you guys for joining us.
No problem. All right. Oh, that's not very good. Hold on a second now. Oh boy, my lighting is. Hey, Pedro. Hey, Dennis. Let's see here. Oh, hey, Albert.
Hey, Lawrence. How are you doing?
Doing great. Doing great. All right. All right. So, are we starting? Vicky?
It's all yours. The floor is all yours. Thank you so much for doing this, Lawrence.
Oh, no problem. No problem. Well,
and thank you, panelists.
Yes, absolutely. Well, thank you all so much for coming today to the East Coast RepRap Festival. It's wonderful to see you all today on this Sunday. I want to just go ahead and get started. This is a panel on diversity in 3D printing. My name is Dr. Lawrence Nightingale, and I am the evening weekend coordinator at Northern Virginia Community College. And this panel is going to give us an opportunity to kind of think about some of the ways in which 3D printing and diversity interact. And so the first thing I want you all to do for our panelists, so we get to know everybody, is I'd like for you to tell us your name, how many years of experience you've had in 3D printing, how you use 3D printing, and what machines did you use while you were doing it, along with the materials and the industries that you used 3D printing in. And so I'll go ahead and start first with Dr. Vega.
Lawrence, thanks for having us on this panel. And again, welcome to everybody. Again, my name is Albert Vega. I'm CTO and co-founder of a small company in Alexandria, Virginia called Building Momentum. Got about 8 years of experience with 3D printing. I think it started about 2012. My intro to 3D printing didn't happen in college. It happened in a weird way. I learned in preparation for going to a battlefield. I actually learned 3D printing because I was going to Afghanistan, and the group with the Army that we were working with was called the Rapid Equipment Force. And we were one of the first, if not the first group to do 3D printing in a battlefield. We primarily use it for teaching, for training. We love showing people that 3D printing plus CAD is a very useful tool so that you can learn things, produce things, create things so much faster. We also use it for prototyping, and yeah, machines I've used. Most of them have been the fused deposition modeling or FFF type printers. Some work with SLA. I think I saw Mara on earlier, so that we've used a couple of Matter Hacker Pulse printers. We use Ultimaker, we use Taz, we use pretty much anything we can get our hands on. A couple Fortis and Stratasys machines, the 250 and what is the 400, which is now I think replaced by the 450. Also a couple Markforged machines. We have an Onyx Pro at work. We helped some DOT partners set up, I think, one of the metal printers. Let's see what else. So primarily we use it for working with our DOD partners, for education, for training, and we still like to make stuff, so we use it for prototyping.
Wonderful, thank you, Dr. Baig. I think that that's a lot of diversity in your experience, and I really appreciate that. Next, I'd like to ask Pedro the same series of questions.
All right, well, thank you for having me. My name is Pedro Martinez, and I'm currently going at Nova, the Woolwich campus. I started with 3D printing for about a year ago in the 3D printing club. I've used mostly the Anycubics, Anycubic Deltas, and also the Railcore. But yeah, most of my experience came from the actual club. That's where I learned most of the stuff. Nova. I learned a little bit of designing with Tinkercad. That's what I use a lot, and I really enjoy it. Yeah, it's been about a year.
Wonderful, wonderful. So it's been about a year that you've been printing, and you use three different types of printers. Okay, very good. Next, let's go ahead and go to you, Dennis. Can you please introduce yourself and tell us about your experience?
Hey, everybody. So I'm Dennis Kuratchenko, and I guess I'm right in the middle as far as experience goes, with 3 years and about 3,000 hours in experience. I've used a variety of FDM and SLA machines, and I think so far my favorite material would be carbon fiber PLA. They're easy to print, but holds up much better than regular PLA or PETG. And I've applied it in the field of education for the past 3 years.
Wonderful, wonderful. Thank you so much. Okay, and so as I said, this panel is about the intersection of diversity and 3D printing. And diversity is ingrained in many things that we do in 3D printing. And so can you tell me how you think business is able to be more diverse using 3D printing? And we'll start again with you, Dr. Vega.
I mean, I love that 3D printing has given us really a tool to attack problems in so many different ways. And I mean, it directly helps out our business, right? I mean, immediately helps us to show people that what is in your mind can actually come out and be in your hand pretty soon. And I think that one of the most important things too is like tying the CAD with a 3D printer, because the ability to create something that's in your mind is super important. But I think it really helps us. I mean, the 3D printing might not be the final solution, but it gets you start moving so much faster so that you start to answer those questions or those unknowns that you don't know. And, it just gets you to that result, hopefully a little bit faster. And it's in multiple different areas. It could be in structural stuff. It could be in educational stuff. It could be in prototyping stuff. And I mean, even just fun things too, just things around the house, things for holidays. You can just create in so many different areas so quickly. And again, it doesn't have to be the end product. I think recently we did a workshop where we showed people how to take something 3D printed and then press it in sand and then cast something with aluminum out of that. So, the 3D printed part is not the final thing, but it got you there pretty quickly too. So
wonderful, wonderful. Can you give us an example of maybe one of the military things or one of the ideas that you guys, it's not classified, that you can share with us that you've used 3D printing to move forward?
One of the ones, I think it's, there's been a lot, but I think one of the ones that kind of stands out is from our very first class that we actually taught with the Marine Corps. We went to 29 Palms. We took a couple of Ultimakers with us. I think we went with a combination of Google SketchUp and maybe it was Autodesk Inventor at that time. Things have changed a lot. But then we had 2-3 days of just intensively teaching some very, very curious Marines. And it turns out that one of the people there looked at 3D printing to solve a problem. They have these mortar tubes that they need to service the firing pin at the very end. And the tool for disassembling that notoriously goes disappearing. And their solution for if you can't service that is to take another 100-pound mortar tube with them, which is not the right answer. So this one person said, I bet you I can create a wrench for that. And he did. And this thing is replacing a metal wrench. And he just beefed it up out of plastic. And it just got a lot of traction. And they even had ways to reduce the material, but still maintain all the structural integrity of this thing. And, even if it breaks, who cares? Take two. It's only a pound or two of plastic, and it's much better than carrying an extra, 100-pound thing around with you. It just, there's just this mentality of plastic sometimes can't fit the bill. And I think the materials changing and the materials sets growing as time goes on is giving people the flexibility with a little bit of creative design and creative, slicing to create very, very strong items that can get you pretty close.
Hey, great. Thank you for mentioning that. I think that as time goes by and we do get more materials that are applicable to 3D printing, the envelope keeps getting expanded. So thank you very much for talking about that specific example. Pedro, can you please tell us about an example of how 3D printing has helped support a business model, a fundraising model, or some of your work in your experience with 3D printing?
With diversity again?
Well, any way that you've used 3D printing in your business, in your education, in your experience, different ways in which 3D printing has supported your endeavors.
Okay. Well, there's actually one time in a robotics club I was in, we were making something that had an Arduino board on it. And we actually needed a specific, shape for the Arduino board to be held in the machine. So we were able to design actually a small tray and 3D print that for the Arduino board to be held on the machine. And that was really useful because it can be the exact shape, the exact size we needed. It was great. And it didn't take long to make because, we can make it less dense and still keep the same structure.
Mm-hmm.
And that was definitely a really good one with our Arduino board. Very useful.
Wonderful. And you weren't able to purchase that tray anywhere else, were you?
Yeah, it's because the place it was in, it would be like difficult to get it in that. It was a small area. So it would be 3D printing was just a better option.
Wonderful. Wow, well, great. Thank you.
Quick and easy.
Awesome. And how about you, Dennis? How has 3D printing supported your endeavors, and what are the different ways in which it's done so?
So to elaborate on what Pedro just said, 3D printing was a better solution for him, but there are some ways we can expand that span of where 3D printing is the better solution. For a business to be diverse using 3D printing, currently it's necessary to use all the modern software, we're at a point where hardware has been established, but the software keeps evolving continuously at a much faster pace than hardware. So things like topology optimization, automation are necessary, and that software is readily and in some cases freely available. And I would like to talk a little bit about total redesign of assembly. Quite often I've heard of companies buying a single 3D printer and printing a part, like for example, that wrench. And then they decide, wow, we've 3D printed it faster, cheaper, and we've saved some weight. Why don't we redesign the whole system instead of that single part? And that's quite often where companies proceed to buy a whole fleet of 3D printers to rely on their core business activities for that.
Wow. Well, thank you for that. I hadn't really come across that yet. I appreciate that perspective. Okay, and so now my next question, what opportunities do you hope to develop from your 3D printing practice? Is the value that you bring to your current employer or to new employers communicated through your degree? And I ask this question because I know that I haven't read about too terribly many digital manufacturing majors in undergrad or even graduate school degrees. There's one that I know of at American University. But Dennis, can you shed some light on that? What opportunities do you think you hope to develop from your 3D printing practice moving forward?
So far, my experience was closer to the makerspace side of things. And I would like to say, I'm not sponsored in any way, but I would like to give a huge shout out to E3D. They're based in England. And I've actually met the president, and we were just talking like two 3D printing nerds at the last year's this event. And only after we ended the conversation, I went to buy something from his booth, and then his employees told me that, yeah, he's the president. Any nerd I was checking, but he was the president of the company. Anyhow, they make really good, cheap regular extruders. They also make volcano and super volcano hot ends that can extrude up to 1.2 millimeter nozzle diameter at very fast speed. And lately I've been working on their nickel plated heat block and nozzle to print up to 500 degrees. And they are the company who makes it cheap and accessible. And you mentioned universities. At this point, I'm considering applying to Penn State University for their additive manufacturing master's degree. So you mentioned American University, and so now you know there is also Penn State.
Wonderful, wonderful, great. Well, thank you for that. And Pedro, the same question. What kind of opportunities do you think you want to develop from your 3D printing practice?
Well, I'm actually following an engineering degree. So for me, I think it would be useful for example, prototyping. We can, with 3D printing, you can prototype very quickly and very cheaply. And I think that's one way that I could really use it. For example, so let's say I want to make a very huge part. I can make a prototype of it I can make it smaller to just see how it works. And if it doesn't work, I can edit it very quickly, make a new one. I wouldn't have to wait for a manufacturing process. I don't have to waste money. It's very quick and easy. And yeah, I think that's what I want to learn from it. I want to be able to use it in the field, engineering.
Scaling things up, scaling things down, and using those prototypes to check out the effectiveness using the technology.
Exactly.
All right. And Dr. Vega, how about you?
I mean, I didn't really learn anything about 3D printing in my college. I'm not going to mention how long ago that was. 3D additive manufacturing was just kind of growing into the industrial area at that point. But I can definitely see its impacts around. I mean, we have a couple different areas in our company, and it definitely affects the prototyping. It allows us to put something in our hands and test things a lot faster. But I think one of the most important things right now is that we're starting to see the educational impact of it. Rewind the clock about 10 years ago, and you didn't see too many people who were coming out of high school who had seen a 3D printer before. Mm-hmm. And now that's rapidly changing. And still, even now, I still have people coming into our space that have never seen 3D printing. And I think that's one of the biggest impacts right now is we definitely want to get both the CAD's portion and the actual physical production portion, the actual 3D printing, whatever method that is, into people's hands, and realizing that that's a tool they can use. That you can find an inexpensive printer, have it at your home, and do creative stuff and even repair stuff, and you can even be an impact, especially during the pandemic right now. You can be an impact to the community and to society.
Wonderful, wonderful. Now, Dr. Vega, I got a follow-up question with that. You mentioned learning how to CAD and using inexpensive machines and putting those tools in people's hands. I think for a lot of people from diverse backgrounds, the expense of hardware is a stepping stone. Maybe it's a bit of a speed bump. I wouldn't use the word obstacle per se, but when it comes to technology, sometimes you have to speculate between the cost and benefit of it. How do you feel about the cost of desktop manufacturing now and the status of it being not as widely distributed among minority populations? And how do you think we might be able to have any effect on that if you think it's something that's substantive?
That's 100% true. It's not an insignificant cost. Thankfully, the cost has been coming down. I think in the last 10 years, it's been a race to the bottom to see who can produce the cheapest hardware, but it's going to hit a limit. It's just going to hit a limit, period. And so the next steps is how can you get more reliability, more quality, other types other than the FDM, FFF style printers to be less expensive. I mean, look at what Markforged and a couple other printers are doing with getting metal printing kind of to a desktop stage. There's some other processes involved in that, so they're not exactly desktop, but you can produce green parts desktop. So I think that there's a good race to the bottom with hardware, especially in the desktop ones that we commonly see. The other nice thing about this, I think another panelist had mentioned this, was computer design is becoming either free or very powerful and very accessible. So that's very important. Lastly it's just how can you get access to that? And I've started to see more and more libraries and community partners engaging in things like this and people opening their doors. We love to open our doors and have plenty of events, and we'd love to even do more. I think that's one of our nonprofit's goals, is to get more of the community and maybe some of the underserved community into our space so that we can have people get this experience and realize that it is, within their reach. And again, it's just getting the word out, finding novel ways to get people access to classes or access to inexpensive equipment, get it in schools, get it in libraries where public access is available.
Thank you for that, Dr. Vega. Now, Pedro, you got some experience with granting access to underserved communities and schools for 3D printing and also for robotics. Can you tell us a little bit about your experience with that? And what do you think were the highlights of it? And if there was any way to improve it, what would you suggest?
Yeah, so I helped mainly with middle school students. I showed them some 3D printing, and they're really excited about that because you can make anything, and they like watching the machines. I like seeing them excited, seeing them excited about technology and just something really good to learn about. I also showed a little bit of robotics using Legos, and I like that one a lot because with Legos you can also make things you want because you just place the blocks. And it helps them think about problem solving. So you got to make a machine. I'll give them a task. Let's say there's a box. You got to make this machine that will walk over to the box, pick it up. They got to think about, all right, how am I going to pick it up? Am I going to make a claw? Am I going to make like a scooping? You got to scoop it up. How am I going to make it walk? Am I going to use wheels? Am I going to use treads? That kind of thinking is just really good. I guess I'm excited too because when you think of Legos as a kid, it kind of thinks you kind of think it's a toy, but they're learning at the same time. They have fun, they're learning. It's really good.
Wonderful.
The only thing is, I guess, the way you can join the two together is getting. Let's say they want to make. So let's say picking up a box, they want to make some sort of claw, and that piece doesn't exist for Legos yet. We could make a piece that attaches to the Legos, and there you go.
Wonderful, wonderful. Thank you for that, Pedro. Just a quick follow-up. How many students do you think that you came in contact with through that after-school program, and how many of those students do you think were from diverse backgrounds, roughly?
So I know I had more than 10 students, and there was definitely a lot of diversity in there. There were lots of different kids. There were kids who or taller kids. There are a lot of kids who had experience with it. Like they had parents who had 3D printers at their house, and there's some kids who just really wanted to try it. It was really, there were honestly a lot of kids there who had completely different backgrounds. And honestly, most of them have fun. A lot of them did enjoy it, even though they have completely different backgrounds on it.
So, all right, well, great. Now, and so also want to follow up with you as well, Dennis. Dennis, you have worked as a 3D printing technician at two of the most diverse higher education institutions in the Commonwealth of Virginia. And so tell us about what your experience with the diversity of practitioners is around 3D printing.
Yeah, I love the variety of requests that are coming in through. Sure, every day I get a few students coming in and asking to print, you know, a Pikachu or something silly like that. But I help them with that, and I've tried to explain them that yes, there is definitely much more to the technology. And later, I worked at particular George Mason University for the last 2 years. And in second year, I saw a lot more of the same students who came to print something silly, coming back again to print something more functional. And one of the students specifically was a student whom I helped to design a TPU, the flexible material, Mars rover wheel challenge. So that's work in education. That's the effort I try to put. That's the contribution I try to make, explaining to students, yes, there is a lot more to this technology. Sky is the limit. And I would like to elaborate on what Dr. Vega said on the race to the bottom. Yes, hardware and cheap 3D printers, desktop FDM is definitely racing to the bottom, but the part of it I'm excited about is that something like Markforged, something closer to industrial or breaching hobby and industrial levels are also racing to the bottom. And I'm looking forward to see where it's going to end up in, say, 5 years.
Well, thank you for that, Dennis. I'm looking to where it ends up in about 7 years because somebody's going to buy one of those expensive printers and then put it on the secondary market. That's where I pick up my hardware. So there's a lot of different ways to do it. All right, so now, we have had a request for our panelists to present social media identities. If you all have any social media handles that you want to share with the East Coast RepRap Festival folks right now, here's your opportunity to do so. I've never done that before. I'm a little bit old, so anybody?
I do have a Twitter account. I don't use it often, but if you do want to follow me, it's Pedro and then 4 4s and a 7. I'm not really that active, but yeah, there you go.
All right. Dennis?
Yeah, the only social media I have is LinkedIn, so feel free to find me on LinkedIn. It's Dennis Kuratchenko, DENYS.
Okay, wonderful. And Dr. Vega?
Yeah, the best resource for us is just go to our website, buildmo.com. It's buildmo.com, and you'll see all of our information on there on classes and what we do. Plus, I think it does have, I think all of our social media links, plus some of our pets that we bring into the office. So,
wonderful, wonderful. Thank you, Dr. Vega. I personally don't have any social media outlets that operate like that right now. Thank you for the motivation. I guess I'm gonna have to start doing that. All right. So next thing is that you know, we're dealing with a pandemic right now, COVID-19. So how do you all think that COVID-19 has made changes in the way that businesses can be started or that ideas can be pursued? And is 3D printing a good technology to build a business from the ground up? So Dr. Vega, if you could take this question first.
Yeah, I think definitely the pandemic has forced us to understand our own resilience and our method of communication. I've seen so much more telework from home and I mean, for necessary purposes. But I think that it's really put a lot of pressure on our resilience and how creative we can get to exploit different things. I mean, our own business, a good portion of our revenue is from having people come into our space and using the events. And another good chunk of our revenue has been, you know, us going to different places, even globally, to administer some of the classes that we teach. And all that came to a screeching halt. So we had to pivot and focus more on our prototyping, for which we turned into, a couple of COVID-related responses, which was making masks or making UVC specific devices. And, we've just been trying to help out in as many ways as possible. And in terms of directly impacting the pandemic, I think there are opportunities for people to use 3D printing right now. We used 3D printing not as the end solution, but as a solution to get us to a mask production path. I think we ended up making a couple thousand masks for different people at for different needs. And we first started thinking, well, can we 3D print them all? And it turns out that probably wasn't the fastest solution given the equipment that we have on our site. And what we ended up doing was doing the end of the 3D printing vacuum formed masks. So we can make, 8 masks in every 5-10 minutes. And then all of a sudden our production rate went a lot faster. I mean, we do have a decent amount of printers, which we could have running all the time, but we were using that more for like visor holders or for other things that don't take quite as much time. So I think there are opportunities that 3D printing will get you to a solution, again, because right now with the pandemic, we need to react quickly. And I think using and relying on 3D printing and other rapid prototyping tools helps us get to these solutions and these rapid iteration cycles a lot faster.
See, and so just to clarify, what you're saying is that 3D printing is a tool to make sure that business moves at a pace that's necessary to keep up with the needs, especially when we can't come together and collaborate and work in person.
And even if it is like, because I still feel like there's a place for injection molding and a lot of these things that are very, they just handle the mask quantities. But when those supply chains or there's gaps in those supply chains occur, that's where I think this part of the Tele network of bunch of 3D printers can actually hand that. You can send out the, for lack of a better phrase, the bat signal and have 100 different people in 100 different places just having their 3D printer running as fast as possible. So seeing the community react to this and seeing the wide stretch reach of 3D printers around the United States, it's easy to connect them and it's easy to, hey, can everybody print these files, combine them, and then get all the output to somebody who needs it.
Oh, thank you for that. And thank you for mentioning kind of just the distributed model of production as well, especially in relation to COVID. Thank you, because that's one aspect that I didn't think about very much. How about you, Pedro? How do you think that COVID has affected the way that we think about the practice of 3D printing, and what do you think 3D printing can do to serve for somebody who wants to start a business, maybe a college age student, or maybe somebody who has a smaller, more specialized type of interest?
Well, I agree with Dr. Vega that he was saying that, yes, there are a lot of downsides, but there are some opportunities as well. And a big example that I think of actually was near the beginning of COVID. I believe it was in Italy. There was a hospital that needed a replacement part, and they couldn't afford it. It was very expensive. So a man quickly, I don't know how long it took him. I think it took him a couple hours to design the piece and print it out. Now, it was just a temporary solution, but it definitely helped out the hospital until they can't afford it.
Wonderful, wonderful. Thank you. And how about you, Dennis? How do you think that 3D printing is going to present opportunities and options for COVID solutions and also establishing itself moving forward?
So, as Pedro mentioned, they couldn't afford it. Afford is one thing, but disrupted supply chain currently, also due to COVID, is whole another thing that 3D printing fits the niche perfectly of supplying the break gap between the disruption in supply chain. And previously, Nightingale, you called it a speed bump of getting into 3D printing. I believe that can be gotten over with in two ways implemented concurrently. I think for a starting business, it's a great idea to get something like, well, we all know, $100 to $200 3D printer that will be shared among the team, say in the office. Mm-hmm. And then using 3D printing services such as Xometry in Maryland or Proto Labs in North Carolina for some of the more advanced, more demanding applications, and try it out that way. And
go ahead. I'm sorry, go ahead.
I also believe 3D printing is better at supplementing business rather than basing it entirely around 3D printing? I will stop there.
Well, that's great. That's great. And, you know, I thank you for bringing up the concept of starting with a desktop unit and then increasing the kind of the complexity of the production as the business needs grow. I don't think that's something that many folks have considered. So I really appreciate that perspective. Okay, so the next question I have is talking specifically about education. Okay, and we mentioned it a couple different times, teaching in middle school and also learning ourselves, military learning, 3D printing, and also graduate school opportunities, that kind of thing. What do you all think are the positive things that 3D printing brings to higher education or to the college experience in general? And what led you to 3D print in college or 3D print after college, let's say? So we'll start with you, Dr. Vega. It was after college, we already know.
Yeah, again, you know, college long ago. Even in grad school, I mean, I really hadn't gotten a chance to do any additive manufacturing until getting deployed overseas. And I think the impacts are, I don't know, it's kind of, the sky is kind of the limit, right? It's educational, it's in your function, in your creativity. I mean, there's so many times that we were creating a solution in one aspect where we had to think about, well, how are we going to machine this? Well, maybe you don't have to machine it. Maybe you can actually print it with additive manufacturing. Maybe your solution is a part machined product and part additive manufacturing. So it's just embracing the new tool. And again, it doesn't have to be a silver bullet. It doesn't have to be the end all be all, but combining and always thinking about optimization between, can I use this? Can I use this? Can I use these other different methods to produce a more rapid or more optimal solution? And I think it also really helps the creativity, your limitations for what you want to do in terms of manufacturing or creating something has started to come down. And I mean, again, I see now that there's 3D printers in high schools and even in middle schools, and just getting that mentality that you can create, you know, bespoke items or things that can blow up into, you know, great solutions, you know, at any time really. So I think it's empowering. It gives you lots of creativity, and it just helps the problem solving process so much faster.
Thank you very much. I appreciate that. And so really the thing about it, it seems like from your kind of echelon of advanced degrees, not really having access to the amount of time that you've been able to 3D print, you've seen it get more and more accessible, and you can see how that access creates more possibilities, more creativity, more ways to help people learn how to solve problems. And I think that problem solving is something that we really strive a lot to get our students to master as educators. Okay, Pedro, same question for you. What do you think are the positive things that 3D printing has brought to your higher education experience? And really, you know, we've already talked about the engineering and the design part. Is there any other aspect of it that you think is important?
Yeah, also the problem solving part, obviously that's really good. I really like the idea of it for as it being a tool, you know, it is a tool, like Dr. Vega said, that it's not going to be the end all be all. It is going to be a tool. For example, we can use it for small repairs. If we're thinking like small scale, like for me, there's a vacuum I have, and this is small, but this vacuum doesn't stand up, and it's just a small piece I can replace. I can make that very quick problem solving, and yeah, I can make that really quickly too. It'll help. But yeah, I think it definitely helps. It definitely helped me with engineering. It helped me figure out that I like working with machines as well, because when I first went to college, I said I want to do engineering. I wasn't quite sure which route I was going to take. So I started with robotics, and then I went into 3D printing. And that was kind of my segue from robotics into 3D printing. I really enjoyed working with it. I like the idea of it, making stuff. And it just really made me enjoy working with machines and working with 3D printing. And that, I think it really helped me solidify my choice with my degree.
Wonderful. Well, thank you for that. Now I'm going to I want to follow up real quick with your response and ask you, Dr. Vega, you know, engineering, computer science, those are academic pursuits that are lacking in a lot of diversity in both their practitioners and also in the students that decide to join them. Do you think that students from diverse backgrounds like Pedro and also Dennis, who was an international student. Do you think do you see in your own experience how 3D printing has provided an opportunity to kind of exercise that mentality of engineering and problem solving, and maybe and how do you think it's affected the kind of the opportunity for students who might be first generation to college or might be unfamiliar with engineering? How do you think it might be affecting that process for students from diverse backgrounds or anyone from a diverse background?
Right. I think that the impact is nothing but positive. One of the things that I forgot to mention was having 3D printing as a tool to just try something gives you the permission to just get at a problem. And you don't have to have all the education. Again, I think a couple of panelists have mentioned that, how easy and how freely available computer-aided design is, how many tutorials are out there. I mean, there was I think the wrench was actually made lighter by topology optimization. And so you can just go find a tutorial on that. And you don't have to have all the education to necessarily get started anymore. It removes that barrier, or at least it lowers it. And again, access to 3D printers is still a little bit of a barrier, but I think all these opportunities to just get people started. And again, I think Dennis mentioned that even if you're just printing something silly, that means you have contact time with 3D printing. It's becoming less and less of an unknown and more of a, hey, when something does spark, you can actually do that. And I think getting people to feel like, can I be a problem solver without having to enroll in, get accepted to, and find the funding for a 2 to 4 year educational program? No, you can still do that. You can still be a problem solver, and you can break into these areas and solve problems and be creative. And I think that these tools that are available now and becoming more widespread are helping with that mentality.
Wonderful. Thank you. Thank you very much for that response, Dr. Vega. And Dennis, I know that in your practice, you are like problem solver extreme. Okay. Now you solve a lot of problems both within at least 2 settings that I know of for sure. How do you think that your experience with 3D printing has helped you to develop and to strengthen those problem solving abilities?
You also asked what are the positive things about 3D printing?
Yes. Go ahead. You can have either one. Answer both of them or one. Doesn't make any difference. I
would just like to say it's such an empowering technology in the effect of it. I would compare it to mass production back in 20th century to what it brought to the masses. It's just so accessible at this moment, brings so much to the table. First time I saw a 3D printer was in a tour of a metal shop, and it is a metal shop. And I'm sure, just like Dr. Vega said, they were combining 3D printing with some metal or machined parts. I'm sure they've done that. But to demonstrate the technology to us, they just made whistles, like build plates, hundreds full of whistles. And even though that was my first contact with 3D printing, and because it was so limited, it took me a year to realize that, yes, the sky is the limit, and that's the effort I was trying to make on students to explain that to them.
Wonderful. And so the sky is the limit. Have you, while you were either at Mason or at Nova, is there an example of somebody who you've helped kind of reach that sky's the limit type of thing, or at least close? Gone from 0 to pretty fast. Not 0 to completion, but is there an example of how you've seen the technology or help somebody use the technology in that kind of way?
Yeah, the best example I keep coming back to is the Mars rover wheel, because we started prototyping it with disconnected, say, walls of PLA that would bend on impact. Then we switched to TPU, to a flexible material. And then we realized we're using 3D printing. We don't have to have equal density. So we designed the wheel with inner and outer layer. Inner was much more dense, and the outer was much more loosely packed. So it was like similar to a variable rate spring in a wheel form. And I don't think he won the challenge, to be honest, but he was among the top competitors.
Wow. Well, thank you for sharing. That's a pretty cool concept. I really appreciate the opportunity to know a little bit more about that. Okay, so now the East Coast RepRap Festival has it features a lot of 3D printing practitioners and people 3D print with a variety of settings, with a variety of machines, and there's a full host of things that they do with them. So what would you like to see at an event like the East Coast RepRap Festival that maybe you haven't seen at any kind of additive manufacturing events or collaborations yet? And what new practice of 3D printing do you think is the most exciting right now? Dr. Vega, we can start with you.
Yeah, I mean, I just like seeing that in events like this, people are always pushing limits. The one thing that I do hope that there's continued focus on, I think a couple of years ago, I went to an additive manufacturing summit at Oak Ridge, and two of their long list of main goals was, one, bringing down the cost of materials. Again, we're seeing the cost of printers come down, and we're starting to see the cost of what you could call prosumer printers also coming down. So that's always really good. But cost of materials, like just even like the cost of, I can't remember what they said their average cost per kilogram was at some point in time for materials, and especially the more interesting materials, high temp materials, carbon filled materials, things that you would get a little more strength out of. And the other one that I really want to see continue to blossom is the speed of which we 3D print. Again, that's one of the bottlenecks, and seeing, you know, larger nozzle deposition capabilities is fantastic. Multiple nozzles, you know, let's get creative. Let's see what we can really do. What crazy ideas can we really adopt into creating, you know, more capabilities through either materials or through speed of making.
Oh, thank you. And I think that that's crazy ideas are probably this is probably the best place for additive manufacturing for sure. Pedro, for you, the same question. You know, what kind of things have you not seen in the 3D printing community that you would like to see moving forward?
Well, I just want to say that from what I did see at last year's festival, because I haven't seen this one much, was really, like, what I did see was amazing. For example, the having multiple nozzles to use separate different filament colors at the same time, that was really interesting to me. One where I believe I saw one day where they used chocolate. That was very interesting to me. All that's crazy. But I guess since it's only been a year for me, one I really want to see more of is metal printing. I think it's not the most original thing, but I think it's just because I just want to see it. It's interesting to me. I've seen plastic is very cool. Using different nozzles is really cool, but I want to see like more of the metal one. That was really interesting to me. Using the powder metal and turns it solid, all that.
Wonderful. Okay. Great. Yeah, the metal printing and the more accessibility of it, I'm very excited to see that move forward too. How about you, Dennis?
So even though it is a RepRap festival, I would love to see more of a prosumer machines, as mentioned before, and something closer to RepRap core, where it's coming from. I would love to see more heated enclosures for 3D printers and high temperature extruders and materials such as glass-filled nylon or carbon-filled nylon. And something I haven't seen much of yet, but I would really love to see, is some tough SLA resin. Tough is an actual term for high-strength SLA resin.
Wonderful, wonderful. So now, Dennis, there's a cache of RepRap style printers out now. Probably the one that most of us are familiar with is the Railcore. So my question to you is, now the Railcore, I think that would have been a prosumer printer for sure 5 years ago. There's no doubt about it. What do you like? Are you familiar with the Railcore right now? Have you ever used one?
I think I've used HBot, but not Railcore.
Okay. All right. Okay, good. I'm trying, because I want to try to get an idea of what your definition of prosumer might be, because that definition is changing. The speed, the accuracy, all those things are becoming more expensive as well. And so I wonder how we as practitioners and also as the industry evolves, you know, what's the definition of how we come to understand prosumer? Because just like a lot of technology, you know, the very fastest and largest and biggest machines, you know, are capable of doing the most, but 10 or 15 years later, you can fit it inside your phone conceptually.
Mm-hmm.
So that's an interesting. That's a really, thank you for mentioning that. But the prosumer definition, we got to make sure that we're on track with it. Okay. So at this point in time, I would like to open it up to questions from the audience. So we've got another 12 minutes or so. So we got time for 1 or 2 questions if the format allows it. Are there any questions from from consumers?
Hi, good afternoon, panelists. So far, I've seen just compliments that they're loving the panel. I have a question for me personally. You know, I am on the ERRF board, and me as a community member, you know, if I wanted to be a good ally and make sure that the underserved communities are feeling welcome to our event, do you guys have any tips or tricks or advice? I know Dr. Vega had mentioned having events and, you know, making sure the underserved communities are invited. But yeah, what can we do to make sure that we're the most welcoming that we can be?
I think one of the most important things that you can do for reaching out to either an underserved community or a community in need is just repetition. I think being there and a present, I mean, if you can do things during great events like this, that's fantastic, but kind of reaching out throughout the year at either smaller events or just getting people excited about it, building like a little bit of a community so that then they know you have reach out or outreach to a bunch of different areas. I think just the consistency and just knowing that you'll always be a partner with everybody out there who just wants to learn and try something
new. I can answer that question too. I mean, I'm a moderator, but
yeah, go for it. Well, now I'm the new moderator, and you have my permission.
I think the easiest and most straightforward thing is to go ahead and just create practitioners. And so how do we go about doing that? You know, in COVID, it's pretty doggone challenging. It's even been challenging for me to keep my students practicing in this environment. However, you know, creating practitioners in schools that are, there's a category of schools called Title I schools. So Title I school, all the students in the, a number of those students, maybe more than half of those students are qualified for free and reduced lunch, right? And so I think that ERRF members who are interested in creating more diversity in the practitioners, just home grow them. Go into a Title I school, see if you can't partner with the principal, get your background checked, get yourself cleared for safety. I can be a consultant for putting together, and Pedro as well, would love to be paid to put together a curriculum. That goes the same for Dennis. And so we've got curriculums. I've got curriculums already. Going into those schools and putting them in there, showing students that they can use the technology, just like Dr. Vega said, really moves things forward. People don't understand that they are capable of this right here, right now. That's what I would say.
You know, your advice might be easier to follow than you know, because my kids actually attend a Title I school.
Absolutely. Actually, you know, I've got a colleague that we're putting together a design challenge right now that maybe we might be able to key into for this spring. I'm working with Nova Labs and the Future Kings, which is a organization that works to give technology to students from diverse backgrounds. So yeah, I mean, we've got something on the burner right now that we can do. Pedro, you got any ideas?
I think, yeah, getting in touch outside of it is a good idea, because sometimes the hardest part isn't, you know, sticking to it, it's just starting. And I think once you start, it'll be good. So yeah, I guess just trying to get people started, because if you help someone in the beginning phases when they don't know much or they're having trouble, I think it'll help them stick to it more, because they'll feel motivated. You know, they'll feel more motivated.
Dennis?
Yeah, you mentioned, I agree with what you and Pedro said, and I would like to add to that, once you get the students started, I would love to remind them of the enormous 3D printing community online. While it may be hard to find somebody else in person in your class, in your school who 3D prints, there is a huge community, extremely helpful community available online at any moment.
Yes, and one thing I would say, thank you, Dennis. You're right. You're absolutely right. The forums are a huge asset for solving problems. And I think that one way in which 3D printing is different from a lot of technical pursuits that people get into nowadays is that the 3D printing community is supportive of new practitioners. And if we, as a group, remain supportive of new practitioners, we can't miss. However, when somebody comes on there and asks a super basic question, it is not to be taken upon us to do anything but answer the question so that person can be helped to move along. I think that's going to make a huge difference too. And thank you for mentioning that, Dennis. That's my answer.
Thank you, guys. I think I might be able to steal more time for another question.
Sure, go ahead.
Okay, I think it brought up, we talked a lot about YouTube videos and the availability of tutorials. I'm a female software developer, and I've done some girls who code classes and everything like that. And we like to think visibility is important. That hi, I'm a female and I'm doing coding. Do you feel how important is visibility of makers of color here, or is it doesn't matter because there's so many free tutorials and resources out there?
Okay, well, I mean, I would respond that it's important, but it's not crucial, right? Because, in my opinion, because 3D printing is it's still just in its kind of beginning stages. If we allow for ourselves to try to create users from diverse backgrounds now, that visual will solve itself. I also personally am it's part of as the person who set up the 3D printing lab at my college, and as the person who administers it, hires the people who work in there and trains them, and then supervises the lab. I communicate to my employees that diversity is crucial, that new people coming in are absolutely the lifeblood of what we're practicing. And so my messaging is always, a woman comes through there, whatever you're doing, you drop your wrench and you make sure that person gets the experience that we're looking for, which is a positive experience, welcome them in, answering any questions for them, and making sure they have success once they exit that door, so that they can then maybe tell their friends or bring somebody else in. So I think that communicating that as a leader is probably just as crucial for getting that participation from gender diversity and also from ethnic diversity as well.
Does anybody have anything to add?
Yeah, I love seeing diversity in these kind of atmospheres, because just again, seeing how widely spread this community is, it's kind of a point that says anybody can be really successful, or anybody can be a problem solver. I do like the ethnic diversity because then it also provides a value or point that says somebody like me can do this. I also like seeing experience diversity, because then you can see another new person, advancing. And you can also see the people who have had experience in that become good teachers in helping the younger ones grow. I think kind of celebrating that and kind of welcoming even in ideas, like the diversity of ideas is very important, because engineers might solve problems one way, but musicians might solve another problem in a different way. So I love it. I love seeing when somebody can spot something in there and say that person is the same skill level, looks like me, is from a similar background, or has the same education, whatever, and says this is truly something where anybody can belong.
Pedro and Dennis, are you guys good? Or?
I would say, yeah, I think that's just very well said, having just a lot of people, trying to welcome as many people as possible, because, some people may be better at designing, some people may be better at the electrical part, and you got to have as many people as you want. If you want the best results, you got to try and get as many people into it people who are experts on certain things can help teach other people. You know, we all learn together. We learn off of each other.
Yeah, and Dr. Nightingale, when I was working at ERRF,
Yes.
remember we had open hours that are posted on a big sign on the door. Even though it was there, people were passing by curiously because, you know, they look in and it's, you know, machines are moving, something looking scary. But those who stood in the door for even a second, I've tried to do just that, drop the wrench, come up to them, explain them, hey, these are 3D printers, these are what we're doing, and then try to learn a little bit about them and tie their background into what we're doing there and see if there is something they could make use of 3D printers. Just welcoming anybody who's even slightly interested. That was my impact on it.
I love that. All right, don't want to step on Lawrence's toes too much. We do have 1 minute, and so I'll let you wrap up. But I do want to thank all of you for taking the time and coming and joining with us today. I really appreciate it.
Well, yes, thank you all. And thank you, Vicky. And I want to thank our panelists for participating today. It's been a good experience. And, you know, the commute was, man, let me tell you, unbelievable. But thank you guys so much for joining in. I really appreciate your participation. I appreciate the fact that I've been surprised by many of the things that have come out of this. So it's great to do kind of a little bit of alchemy, put people together and see what happens. So thank you all. And I'll see you soon.
Thanks for having us.
All right, you take it easy.
Thank you. Thank you for watching. Thank you, everybody.
Thanks, East Coast RepRap Festival. All right, bye-bye now. I guess I'm just going to quick leave, Vicky. All right.
That'll be great.
All right.
Bye.
Oh, wow. That was just a lot of good stuff. I'm going to be unpacking that. I think I'm going to be unpacking
all the
panel
panels give you a lot
conversation.
of homework.
Yeah, it's so much homework to be thinking about, just a lot to kind of process, which I love. I love thinking. I feel like I've done a lot of thinking today and over the last couple of days. So excellent. Well, Vicky, I'm looking. I don't see anybody in our waiting room. And I know that auto drop was supposed to be up at this point. I've checked over on the other channel and they're not there. So 30 minutes of Vicky and I doing improv. We totally got this. No, we'll give it a couple of minutes and see what comes up or what's happening. And see if auto drop is able to drop in on us. Boom ching. There's my easily attained pun for the moment. Oh, I'm seeing things come in. Oh, no, that's a different thing. So I'm not hearing anything from auto drop at the moment. Vicky.
Yes.
We talked at the beginning of kicking off Build Platform Day 2 today about things that were super cool that we saw yesterday and that we got to experience yesterday. Is there anything, and I know I'm putting you on the spot, is there anything that has come up so far today on the Build platform that has blown your mind?
I think you're not putting me on the spot because I threw it in the chat. I really responded to Paul's presentation on chemistry in our garden, and everything's making sense now. On the other channel, he mentioned tulip poplars this morning, and he already made my heart pitter patter. I love tulip poplars. I love trees. I love hiking. I love nature. So this just really tied in to my outdoor passions with my indoor 3D printing passion. So I really enjoyed that presentation.
Yeah, I thought the same. I thought there were going to be some possible applications for the new house and the new garden and things to kind of tie some different things together, which I think would be great. Love that. You know, everything today has kind of jumped out at me as well as I think about Slice starting it off with, you know, the their paint, their heat resistant, plastic resistant, everything, not heat resistant. God, I'm just, but it was awesome to hear about that. And again, thinking of real world application and the idea that, for many months we were all doing a lot of printing, and we're still probably all doing a lot of printing. And it's one of those, stuff gets stuck to your nozzle, stuff gets stuck to your silicone sock. So the idea that I don't have to deal with that, I love that. I've definitely had a print or two potentially ruined by nozzles getting stuck to things and pulling them up. I'd like to reduce that number as well, if at all possible. And then JWall with, the just, here are some tips that you can use and stuff that was just super cool around that. And then leading into Clayton talking about Nomad and just making it look easy for those of us who are totally unskilled in any kind of modeling. I'm talking about me. And then leading right into Paul, and then again the diversity panel. So much to unpack and to think about. And by the way, really great question at the end there, Vicky, about
I
what
saw
we can
about
all
the.
do.
Oh,
no, yeah.
me.
No, I was talking about you, but you're absolutely right. There, another great kind of comment.
A point of the English tutorials on YouTube.
Yep, absolutely. I saw that as well. The comment regarding lots of YouTube content being in English, but such a huge opportunity for others to be able to jump in and add their perspective. Yeah. I'm also
the shadow puppets.
I saw the shadow puppets. And I was like, yep. You don't want that. I can do a dog and a butterfly, and that's about it. And neither one of those is actually good. But yeah, actually another great comment as I'm looking back at the stream, Alec Perkins noting the surprising lack of social media presence by the panel kind of underscores the last point about meeting people where they're at. Yeah, I think you're right, Alec. It's yeah, social media is its own animal. And then followed up with a comment by Mike Taylor, regarding some people not wanting or avoiding social media because people online can be awful and
be uninvited.
Yeah, and I think it ties in. There was a comment earlier as well. I think it actually might have been Mike up a little bit higher in talking about how there can be toxicity to communities, especially when new people are trying something, which I think ties into what I was hearing in that diversity panel. That idea of, dropping the wrench when you see somebody new at the door or showing up, making sure that you're making it as welcoming an environment as you can for somebody who may be new. Vicky, I know I heard you say I'm a girl who codes. Tech is part of your world, and for me, I actually kind of a different world of hands-on stuff. So 3D printing was all totally new, and it was people in the community who. Oh, I see. What's your thought?
Well, I have a comfort level with software, and for me, 3D printing, there is, hardware aspect of it, and it was intimidating. Like, nowadays I do a lot of color swaps with the filament, but when I first got my 3D printer, I was scared to change the filament. So I just kept printing everything the same color because it was something that was intimidating to me. And I still have, now I have a comfort level with 3D printers, but I still have like this little bit of anxiety with 2D printers. When I was in high school, I didn't have a computer or printer at home, and every time I had to print something for my computer science class, there was like a paper jam or the printer was offline or this and that, and there's just all this like intensity, like having to find a peer and get judged and all that. So now, even to this day, if a printer gets a little paper jam, I'm like, even though I know I have Google and I have all these capabilities now at my disposal.
Yeah, I I was always more comfortable. You know what? I can't say I was always more comfortable with a 2D printer than a 3D printer. I feel pretty comfortable after having ripped one apart many, many times and putting it back together. That's the beauty, I suppose, of getting a tinkering machine or using one that you're going to specifically want to tinker with. But yeah, just the different aspects of everything. Yeah, so much thought. I am looking at the clock and it is 8 after, almost 10 after. I am going to apologize, guys, because I don't think you want me filling up another Lord knows how long.
Especially when
with
there's exciting things coming up on the other channel, because
Exactly.
this was Autodrop 3D was the last speaker of the day.
Yep. I just saw in the chat really quickly when I looked over, every online community needs a Vicky at their front door. I could not agree more. That may kind of push Vicky to the limit, though. I think Vicky's got as much as
I should say, I'm sorry.
No, go for it.
I found the 3D printing community to be very embracing and supportive and welcoming. It was a culture shock, like on Twitter, everybody's so in the 3D printing community, everybody's so uplifting, that when I did finally run into a toxic community on Twitter, is like, oh my gosh. So I do thank the community for being as positive as we are.
Vicky, I think that's probably a pretty good place to leave the stream,
Yes.
right? We got really lucky, and I think the last couple of days has been a great demonstration of what really happens when the community kind of is able to come together and kind of have these events, and how welcoming everybody can be. And we've heard that through various different things, and we've seen some of it in different aspects. So I think you just gave us our note to go out on, Vicky.
All right, everybody, thank you for watching, and hopefully we'll see you in person next year.
And hopefully we'll see you in the chat over on the first channel as well, because I know I'm heading over there. Vicky, I'm guessing you're probably going to do the same, huh?
Yep.
All right. Well, thank you everybody for the time you spent with us over on the Build platform. Hopefully it was enjoyable for you guys as it was for us, getting to see the chats, listening to all the presentations, and we will see you soon. Bye, guys.